We're getting started. Welcome back, everybody. Hopefully, more people trickle in. A little bit of a thinner crowd today. How'd you do over the week? Did you guys have any fun programming adventures? I'm all about adventure.
I'm working on a QR code program.
Wow, cool. Awesome. Nice. That's very cool. Maybe you can share it with us sometime at the end of the class or later. And we left off on Wednesday where I was showing you some stuff kind of rapidly, and I said, well, okay, here's what you're going to do then. So everyone got 3 points on Lab 1, and then I showed you what I wanted you to do for the extra. You got 7 points on Lab 1, and I showed you what I wanted you to do for the extra 3 points, which was to convert in the lab. You use a separate array of names, and item prices. Remember that? And I said, well, now I'd like you to use an array of items, okay, for those extra 3 points. Did anybody get that? All right. Pablo? Yeah, good. 3, 4, 5, good. Awesome. Great. So for those extra 3 points, you have to finish this using an array of items. And I think that's perplexing to a number of people. My experience is a little shaky on objects, a little shaky on arrays. You get arrays and objects together, forget it. You know, let's just go home. So I actually decided what I'm going to do, because we have this holiday coming up, right? We have Friday's a holiday, and Monday's a holiday. So what I'm going to do is I'm going to prepare. I was going to actually lecture on queues this coming Monday, but it's going to be a holiday. So what I'm going to do is I'm going to actually prepare an online lecture and assessment, that assessment type stuff on arrays, a little more stuff on arrays, because I know some people are just, I think it's been a while and never really was too comfortable with it. So we'll do something on arrays, arrays of objects, so you can kind of see how that works. It'll be a little lecture. It'll be some online activities for you to do, and maybe a little programming activity that you can walk through following the slides, so you can do that stuff. And then I'm going to actually do a preview, which is going to be really fun, of linked nodes, which is going to get a little bit of ahead of the game, but it'll for after the test, when we start making a linked bag and stuff, that's going to be really, really cool to see that. So get ready for that. I'll throw that up there. I'll email you out over the weekend when that's ready, and then you can tap into that, because I know there's a lot of need for that. Just working with people, I can see that there's been a lot of 10A had a lot of stuff, and if it wasn't all absorbed right, it can be really really difficult. So we'll kind of approach that so it makes a little more sense over the holiday.
So that'll be uploaded by Monday, and we can tap into it.
Yeah, it'll be uploaded hopefully on Sunday, and then I'll email everybody out, and it'll be something that you can tap into on Monday and work on. Yeah. So. Okay, but before I leave that behind, I just want to show you the thing about this grocery checkout too. So if you were thinking of working on this, and that's where you now go down here and modify these things. So right now, see, this is reading. It's reading an item name and a price from the keyboard into these two separate arrays. And now in this new territory, it's going to look like this. And you guys all got this email, right? So you can mark this up. So you could make an item, say purchase, the thing that they're going to buy, and you're going to use the constructor to make a new item, right? If you make a new item with nothing inside the parentheses, what do you get? No. According to your item class, now you got to remember, this is the code that deals with how an item works. Remember, an item we've decided is a thing that combines a name and a price together. And there is a constructor here, which is the no-R constructor, and if you make a new item with nothing in the parentheses, you get that. And what do you get? The name of it is blank or dashes. The price is 0. Okay. Well, what if you decide to make a new item and you say something like tuna and $1.99? What do you get? An item, right? One item that has a name of tuna and a price of $1.99. It's all contained in the same little box. Okay, that's the transition into objects that we're going to be doing, and we're going to be doing more and more of this for the rest of the semester. So by the end of the semester, you're going to have objects coming out of your head. Now I drew a picture of this, I think, at the end of class, and I think I saved it in here maybe. There it is, memory map. Kind of ran out of room there on the bottom, but you can kind of see where. Now what we want to do though is we want to remember all these things, right? So whereas in the first example, each cell in the array of names was actually referring to a string, now we're going to have each cell in this array referring to an object. Okay. For instance, tuna or something. Yes, Christian?
So when you create the object, since it knows that has a string that has a name, does it dedicate enough memory right next to itself to hold one of each of those things immediately?
You know, the thing is, as you start looking into what's going on in these things, it just gets deeper and deeper. And I'd like to, I could draw that, if I could stretch this out a little more. Can I do that? A little bit more. Forget, I used to be able to resize this thing, but they seem to have taken that away. If you actually look at what an item is, so for instance, I just made a variable called purchase. And purchase is a variable that refers to this item. Now, I just made this thing, and it has a name of tuna and a cost of $1.99, right? Now, inside this purchase, there's a variable for the name, right? Now, you're asking, does it make room, enough room for the name? No. Because what's the name? Sorry? Name is a reference to a string object that's stored somewhere else. So the name is a reference going to a string, and inside the string there's the word tuna, right? Apologies for the scribbles, but sometimes that can be very helpful, I think, to see that. Right, inside, that says tuna. Inside that object is a string. And, well, what's inside that string? An array of what? Letters, right? So, nope, it's not there either. Where is that T-U-N-A? Well, there's an array of char somewhere, right? That's a primitive, right? Everything gets down eventually to primitives. It all gets eventually converted to primitives. And inside that array, there's the letter T, U, N, A. Okay. Where is it? Who cares? But we know how to get to it because all these references are referring to those memory locations to get there. Okay? Right. So, and we don't really need to blow it up to that level of complexity just to kind of do some simple modifications. We can do simpler models and just imagine, like in this drawing, that this item has a name and a cost inside. Oh, and by the way, the cost is a primitive, so the cost is actually stored right there. And there is memory for the cost variable and for the name variable, but those are just references to where the actual data is stored if it's an object. If it's a primitive, like cost here, or I guess it's price, the price is stored right there. Okay? All right.
I have a quick question.
Sure.
Lab. So what if
Okay.
we generally have an idea of how we're supposed to do it,
Mhm.
but we're kind of stuck on a couple of areas? Can we get little hints? Like, can we get a chance to still turn it in today and get?
Yeah. No, you can keep working on it. You can turn it in Wednesday, whatever.
I generally kind of know what needs to happen, but I'm kind of having some issues with.
And that's where a lot of people are in this class. Yeah. And this is.
Concept with when you create a new object, and then with arrays we have to use the loop to iterate over the different spaces in the array, but we're creating a new object every time.
Yeah.
So I'm just kind of stuck on that.
And I'm going to give you a little more of that. That's why I'm kind of showing this. So we just looked at the grocery checkout and we said, well, if we set a new item of tuna, $1.99, well, that's great. But inside this array, we're going to create, if we're said we're buying 4 items, each item that we buy is going to be the same thing, right? It's going to all be tuna. Well, we don't want to buy tuna. We want to let them type in what we're going to buy, right? Well, that's why, and I showed you how to do this, there's a third constructor in the item class. Okay. And so this is the one we just used, where we used tuna and $1.99 for that, but there's this one here called item that takes a scanner in. Look at that. Okay. We give that constructor a scanner. What does it do? It reads the name and the price from the keyboard. Okay, so this is how you do this step. Okay, you say, it's not a new item of tuna, it's a new item of keyboard. Okay, the scanner that we created up above. Okay, and now it's going to let us type in the name and the price. And it's going to store that in this new item object it's creating. Every time it goes through this loop, it creates a new item, and then you read the information from the keyboard, and it stores it right in those 2 fields. Okay. Well, how do we get that? Because we got to remember these purchases. How do we get that stored in the array? Remember, we made this array up here. Now it's an array of item objects called items, which is a kind of a boring name. Maybe we should call it shopping cart. That might be a little bit easier to think about, right? Shopping cart is an array of items that we've purchased, right? I see a lot of blank faces. That's not a good sign. I just changed the name. You can change it anything you want, but if we call it shopping cart, that's going to be the array now, and I actually drew the array here. I called it items here, but now maybe would call this thing. Maybe it makes more sense to call it. I need a thicker pencil. Let's call it shopping cart. Okay, it's referring to an array of item objects, and we want to have all of those items referred to by every cell in the array. Believe me, I know this is not easy. This is why you're going to like the bag class. We're going to talk about that in just a couple minutes. Okay, but how do we actually, now we've just made this, created a purchase item. Now we want to store that thing, what we just typed in from the keyboard, we want to store it here in cell 0 of the array. How do we actually move that purchase so now it's actually stored in the array so we can get to it from the array? And the answer is right here. How are we going to now move this purchase so that we can now refer to it by the array? Willie, you can't say anything, and Rico, you already got the answer. I mean, you already know the answer, so how about somebody else? How are we going to flesh this thing out? Okay, so for instance, purchase of index. Remember, index is counting from 0 up to however many items we bought, right? So the first value of index is 0. So the first thing you can say is purchase of 0, but now we want to actually have that cell now refer to the new thing we just purchased, right? Whatever we typed in from the keyboard, that item.
It's not shopping cart?
Oh, sorry. Shopping cart. Bad name. Thank you. Shopping cart of index. That's my shopping cart now. And then there's the one cell, right? It's going to refer to this thing equals. Nope. Purchase. You could actually combine that, though, right? You could move this here, and you could do all this in one line. You could say a shopping cart of index equals new item of keyboard. Or you could say purchase equals new item of keyboard, temporary reference to that object. Now when we say shopping cart of index equals purchase, we're copying that reference into that cell in the array. And what happens in the picture is you see the reference here. That value, which is an address, that little squiggle I'm just writing on, that's an address to where that purchase item is stored. We're going to copy that right here. Okay? And the consequence of that is that now, instead of referring to P's here, this cell in the array is referring to the same object that purchase is referring to. Okay? So we can hold on to that now. The next time through the loop, purchase is going to be referred to a new item. Okay, that's going to have new stuff that we have, whatever we bought next. Okay, we're going to keep trying, but each time we're going to store a reference to that new item in the next cell in the array. So eventually, the array is going to refer to all of those objects. Christian? Yes. That's already taken care of for you in the grocery checkout 2 program. We input how many items we were going to buy. So we said how many items. We input an integer for num items, and then we made item of square bracket shopping cart. In other words, array of item called shopping cart is a new item array with num items in it.
Is there a way to do it where you can just not have to punch it in initially and you can just add items
Yes, but
with an array and not with an array?
yes, but you have to do the algorithm to do that. You have to make a new array that's bigger, and you got to copy all the data in the old array over. And you're going to do that later on in this class.
Okay, so each
Yes.
time you add a new thing, you make a new array one size bigger, copy each object over,
Yep.
delete the old array.
Mm-hmm.
That's your new shopping cart.
Exactly. Yep. Good. Okay, so that's getting you started. So that actually, but then you got to figure out, well, what do I do here? I can't use item price as array anymore. How do I actually get the price of the item I just bought? Average plus equals what?
Shopping cart.
Get price.
Shopping cart of what? Index, that cell number, dot get price. There's a get price method. Or, because it's also referred to by, another way we could do this is what? You could also say purchase dot get price. They're both referring to the same object. Okay?
We can only use purchase inside the loop, right?
Yep, afterwards purchase is not going to be, but the array is going to hold on to it for long-term storage. Okay? How do you know if you're looking at P's?
Get
Yeah, items of index, again, that's referring to that thing we just typed in. How do we get the name of that item?
get name.
There's a get name method in the items class. How did I know that? Well, I read it, but you can scan the class and see, is there a get name method? Oh, there it is. Yep. That returns the name of the item, so I can actually just say get name. This is where, if you get past the confusion that you're experiencing right now and just understand the picture of what's going on, it's very intuitive, and it becomes real easy to work in Java this way. Everything just kind of, it's just as you would expect. It's all there. All the methods are there. The tools are there. Just got to start doing it, and that's the beauty of Java. If you're still confused about that, though, then you need to kind of do some stuff to kind of clarify it. But we'll get to that later. Yeah, this can't be right here. There's an error here, too. So you can fix that. That's about, actually, you only need to do like 2 more things, and you're all done. So if you take that idea and go on a little bit further, you can get the whole thing working. Okay? But there's an error in what I just showed you on this line, so that one's not going to compile it just yet. Okay, that's as far as I'm going to take it. So I'm going to save that and let you all mess with that a little bit. It's fun. You got to get that kind of clear, so you need to kind of wrestle with this a little bit. And now we're going to go and bring up the lecture on bags. And so the plan is we're going to talk about bags and a little brief lecture. I've tried to chop this down as much as possible. There isn't really much to say. Bags are actually pretty simple. And then we're going to do the lab on bags. And I always hate throwing too much in, but I think we need to go over Eclipse today, right? Because a lot of people want to learn how to use Eclipse. Am I right? So we'll try to stumble through Eclipse and bags. And then I got to talk about inheritance, too. There's no way around it, because we've got all these ideas that come at us. And my approach is, though, this year is I'm going to just bring in just enough inheritance to get you going. And there'll be some activities in the lab you can do. And we're probably not going to finish all the labs in our lab day, so the rest of the labs are going to be homework for you to kind of do just these little things to keep you going and go deeper into this stuff. Yeah, Rico?
So I think you were just about to answer my question, that the labs will just treat as homework and just send them to you?
Yeah, I'll give you like 7 points for being here doing this, but then like the rest of the lab that we're not going to have time to finish every day.
So we'll put it in where it says...
You can upload that to the uploader. Yeah.
Okay.
Is the uploader working?
It should be now.
Because it didn't give me like a success message after.
When did you upload something?
Sunday.
Okay, I just erased and cleared everything, so you have to probably upload it again. Yeah.
Would that be like the C++ upload where you have to like create a zip and then put it up there, or this is like the...
You create a jar in Java. It's looking for a jar file, just like we did in 10a. Yeah. Yeah, when you're done, you can upload that one. Yeah. I'm sorry? Yeah. Yeah, it's easier than me going around and checking you off. It takes too long, the time is so short. I want to get the most of the time spent you guys doing some coding exercises. That's what I want you guys to do. So, So we're looking at bags today, and bags are, in our purposes, they're a finite collection of objects. There's a limit to how much a bag can store. The items in a bag are in no particular order. They're not arranged in a ring. The answer for this one is B. But the items are in no particular order, and you can contain duplicate items. So a bag, you could have many cans of tuna in your bag if you want to. Okay. Question? Okay. We're going to look at how a bag works, specifying a bag. A bag now there's going to be a class for a bag. But today, unlike last year, you're not going to see what's inside, how that bag is coded. You're not going to see the code for the bag class. You're going to have to rely on the documentation for the bag class to be able to use it properly. Okay. We're going to learn how to build a bag after the first test. We're going to open these things up, and we're going to learn how to the nuts and bolts of constructing a bag and how that works. You have to learn. That's why you have to have a review on arrays and stuff, because I know some people are kind of having some issues with that. Inside a bag, there's going to be an array, and how it's all managed is the code and stuff that we'll be doing after the first test. So this should be relatively easy once you get the hang of it. We'll be learning how to use these objects for storing other objects, and then using them in some simple applications. So a bag, conceptually, is a finite collection of objects in no particular order that can contain duplicate items. And if you think about it, this is how you're going to use a bag. So imagine you have a bag, and we're going to have this new thing, this generic thing. You probably saw this in 10A when you looked at the array list class, but these angle brackets are used to specify the things that the bag can hold. Okay, so when we create a bag, it's going to be a bag of string. In other words, you can only hold words inside it. You can't put items inside it, or scanners, or students, or whatever other objects you might have. It can only hold string. And that's actually to help you. That means if you try to put something else in the bag that it's not supposed to have, the compiler is going to say, hey, wait a second, this is a bag of string. You just tried to put a giraffe in here. You can't do that. Okay. So, and that's good, because that prevents us from making really crazy. If it allowed you to put a giraffe in there, later on that giraffe's going to come out when you don't expect it, and it's going to do something really bad to your program. Okay. So we can only add p string. So if we want to add something to the bag, we say a bag.add keys. And the name of the bag is called a bag, right? That's the bag object. That's how you refer to the bag. And then if you want to add something to it, you say a bag.add peas, add carrots, tofu, celery, and then, you know what, kind of sick of tofu. So there's a method called remove, and you say remove tofu, and it goes away.
So a bag is a reference, right?
A bag is a reference. Yeah, let's sketch that out. Let's draw a picture. And anytime you'd like to see a sketch or something, let me know, because we can add a little thing. So memory-wise, a bag is a reference to this thing, which is the actual bag. Now inside that bag, really there's an array, and inside each cell array is pointing to where those strings are. We can go into that, but that's not really what this week is about. From the point of view of you, conceptually, thinking about how the bag works, you can imagine that now the bag has these things inside it, right? We've just added peas and carrots and tofu and celery. Not going to get too fat in this bag. And then we decided to remove the tofu, so the tofu is actually not in the bag anymore. So what's in the bag after all those statements? Peas, carrots, and celery, right?
Now I'm just curious if I'm understanding this right. So peas is just the address, or is it actually? Well, because like you do a string, and the string is what the string is. Is that kind of like that?
Exactly. Yeah. So I want you to think. There's actually for everything that we're going to be doing in Java, there's sort of two ways of looking at it. There's kind of like the logical view of like, you know, here's a bag, right? Can I borrow this? I can stick a water bottle in it, and I can imagine if I was going to sketch this out, I would draw a picture, and I see conceptually, yes, there's a bottle in the bag, right? Same way, I've got peas, carrots, it's all in the bag. Then there's sort of like what's really happening, right? And as programmers, you kind of often have to bounce back and forth between both of those views. my thinking is I don't want to go into what's really happening just yet. And the nice thing is it's simpler to not worry about all that stuff normally, right? It's simpler just to think about the logical view, what a bag kind of conceptually it should do. And that's all you need to worry about when you're using a bag from the application standpoint. All you need to know is, how does a bag actually work? Well, you put some stuff in it and you remove some stuff. End of story. It's pretty simple, right? Later, we're going to actually figure out, well, yes, there's an array inside that bag, and each cell in the array is actually referring to a string somewhere else, you know, and all that stuff. And you could draw it two different ways. But you know how the caterpillar that tried to think about how to describe how to move its legs ended up not being able to walk anymore? That's what happens in Java, right? So we have to think about the simplest model to express these things, and that's what we're going to do. So other things conceptually that you like to do with bags is figure out, well, can I put anything else in the bag, or is my bag full? Do I have an empty bag? That's kind of good to know, right? I like to add or remove objects. Maybe I like to count. Well, how many cans of tuna did I actually put in this bag? You might want to know that, right? Maybe you want to know, does my bag contain a candy bar? Right? Yep.
When you said that a bag is an infinite, it can hold an infinite number of items in the bag. What did it say? It said it was
finite.
Finite. Okay.
Means fixed.
So so it's fixed. So when you actually write a bag, you actually determine how big the bag is to begin with.
Yes.
Okay.
Yep.
Okay.
Mm-hmm. And the default size, if you don't say, is going to be 10. But if you say how big you want the bag to be, it'll actually make it
So
that big.
while you're actually adding more to it, you forget, oh, do I have 9 or do I have 10? Then you can ask it, is it full or is it empty?
Exactly.
Okay.
Mm-hmm.
They're arrayless? What would be the difference?
Well, the array list keeps track of the order that they're in, and the bag doesn't have any mechanism. It's kind of like a really simple form of an array list.
But an array can also expand itself.
Yeah, it's a very simple form of an array list. It doesn't have all those features of an array list. Yeah, array list can resize, can do a lot of stuff. Bag's really simple.
Okay.
We're going to get there, but we're doing it in small steps.
Sure.
A lot of times when you're doing object-oriented design, there is a process of describing a class before you go ahead and write it. And the class is just figuring out, well, what's this bag supposed to do? And you can go through this design exercise. When you do your final project, you're gonna do something really interesting. You can lay these things out. Well, what does this class actually have to do? It's typical. Typically, you don't want to. The first thing you don't want to do is start coding. You want to actually take a step back and just start writing. This is just basic, high-level thinking about, what do I got to do with this bag? And these are just listing all these things, the responsibilities. And the collaborations are, what other objects does this bag have to interact with? And the bag is going to interact with the stuff you're sticking in it. Those are going to be objects of some other class. This is a container class. Objects of this class contain other objects. Okay, so it's a special kind of container. And we're doing this to make our life easier. A bag can be used in place of many instances where you might think you have to use an array. You know how we don't like using arrays? Because of all those indices and the for loops you got to write and all that stuff. You might actually find it's simpler to use a bag. If all you need to do is just store something in it and pull it out later, that could be all you need. And it's very easy to use. And it's less likely that you're going to make mistakes. So your program's not going to crash so often, and on and on and on. We're doing these things because it helps us write complicated programs by making certain things that we do a lot simple. So we described the data that the bag's going to manage, and then the bag's behaviors. Again, we're not going to look too much about how it's actually being done, but just what it's going to do. And then you have to ask the question. There's a lot of these things where, if we all had to design our own bag, we might come up with different answers to some of these design questions. For instance, suppose you try to add something into the bag, but you can't do it. Bag's full. What are you supposed to do?
Create another bag.
Create another bag? That could be an answer. Sorry?
Swap it with something that's already in there, like something else.
Throw out something so you can put the new thing in. That'd be another option, sure. Sorry?
Add to the bag size?
Or increase the size of the bag. Yeah, that's another option, right? So, and in general, there's all kinds of situations where these sort of unusual conditions happen. The bag's full, I can't put anything else in it. Or what if the bag's empty and I try to pull something out of the bag? What should we do then? See, these are all the kinds of situations you get into once you start modeling what a bag is. And you have to come up with solutions to these things. So, for instance, can we assume that something invalid never happens? No, definitely someone's going to do it. So we have to make sure that we plan for that. Can we ignore it? No, that's not a good idea, because then, two different assumptions go on. The programmer thinks one thing and actually something else is happening. Guess at the client's intention, return a flag value, return a Boolean value. You know what we're going to do? Because it's relatively easy, we're going to just return a Boolean value indicating whether we were able to add something to the bag or not. So if we add something to the bag and the add method returns true, it means fine, the thing is in the bag. If it comes back and returns false, then we know that that thing didn't get added to the bag. Okay. Another thing we might do is throw an exception, and we will talk about exceptions in a week or two. I think it's actually next week when we look at queues. Then what happens is we codify the interface. In other words, we start defining the precise names of the methods and the arguments that they take, and then the types of values that they return. And you might remember this. A lot of people kind of get turned off by this. Is a UML diagram. It's a very compact notation for how this class actually works. We need several different ways of modeling what software does so that we don't have to look at all this code, And the UML diagram is a very brief description of the mechanics of how you would actually use this thing. It doesn't even describe what these methods do, but it lists them. If all you had was a UML diagram, you could probably figure out how to use this thing. Because the names of the methods are kind of explaining what it does. There is that letter T there that looks a little strange. You might be going, what the heck is T? Right. No. This T stands for type. In other words, data type. Okay. Because it's generic, the thing that we put inside the angle brackets when we create the bag is going to be referred to as T when you see it in all these methods. Okay.
So what's the difference between primitive and
The difference is you cannot make a bag of primitives. It has to be a bag of an object. Remember those wrapper classes? There's a class double with a capital D, a class integer with a capital I. Those are classes inside an object of class integer. There's a little primitive int. They're wrapper classes, so you could make a bag of capital I integer. And it works kind of just like you would think a bag of primitives would do, but you can't make a bag of primitive things. It can only be a bag of objects. Yeah, there's all kinds of these little things about Java that, but once you get over it, it makes it real easy to work with. It's really, really nice. A slightly better way to model what a bag does is with this Java doc description. This actually gives you a little more information because it describes what these methods are guaranteed to do. It's like a contract, If you use this thing, this is what's going to happen. Okay. So notice it says class bag angle bracket T. Okay. T is the placeholder for the data type that you're going to make the bag hold. Okay. Everywhere else that you see T in there it's just the data type that you're using. So if it's a bag of string, then you can imagine all these things are replaced with string. If it's a bag of item, all these things would be replaced with item. Okay. Now there's two constructors. There's a no-hard constructor, which creates an empty bag capable of holding 10 objects. That's all you get if it's the default constructor. If you want more, you got to create the bag with a certain capacity that's going to allow it to go bigger. Okay. Then if you want to add something to the bag, you say the add method, which takes an object of this data type T and adds it. And it returns true if and only if new entry is successfully added to this bag, the bag that you're looking at. You can clear the bag. What do you think that does? Throw everything out. Empty the bag out. It doesn't return anything. Contains method. How do I know if I have a can of tuna in my bag? Okay, does my bag contain tuna? It returns true if and only if you can find an object in there that matches an entry, right? And then another page, get current size. How many items are in my bag? Okay, it returns an integer. Get frequency of. that means how many cans of tuna do I have? Okay, that tells you the count of how many number of times an entry appears in the bag. Is my bag empty? Is it full? Remove. There's a remove method that just removes anything from the bag. It doesn't. It's like you close your eye. Okay, I'm going to remove something. It's not telling you what it's going to be. It's just going to be something that's in there. Okay.
Do you ever know what it is? Or is it just
It's not supposed to tell you. In reality, I mean, you're not supposed to care. Like if you just want to remove stuff, it's like, I want to process all the things in the bag. I don't know what's in there, but I want to remove something and process it. I want to remove it and I want to print it out. Okay, so I'm going to remove something, and it returns a reference to the thing that's removed so that you can then do something else with it, right?
So you could do like a while bag is not full.
While the bag is not empty,
Remove, and then you could
my bag dot remove, and then you could do something. You could print it out. You could do something like that, right? Mm-hmm. And that's the only way. Well, that's one way to actually process this stuff in the bag. If you just want to actually see what's in the bag, there's a toString method, so you can just print out a bag, system out that print line of bag, and it's going to print out a list in string form of all the items that are in the bag. Yeah.
So remove is literally returning the object, the full object that's in the bag, so you could pass it, you could remove it and put it into something else.
Yep.
Right away.
Another bag, for instance.
Yeah, so you could just pass it from
Yep.
empty one into another one essentially.
Yep. Mm-hmm.
Okay.
Then there's another remove method that says, I want to take all the tuna out of my bag and put it back on the shelf. So you can remove tuna, and it'll just remove, it'll look for an item called tuna. Now, if it finds it, it's just going to remove it. It's not going to actually give you a reference to it. It just throws it out, and it says true. Okay, I got rid of your tuna. Okay, yeah.
Now with objects, does it default to the object's name? Like if you create a complex object, what is it searching for to remove?
It's kind of, we'll do an example in the lab and you'll see. Yeah, some of these things are kind of hard to wrap your head around. There's another one called toArray. Now this is actually a little bit weird. This whole generic thing, you would want this to be, this should say object square brackets. It's going to give you an array back, but it would be nice if it was T square brackets. In other words, if it's a bag of strings, you'd get an array of strings out of it. Java has this limitation, though, with the generics, that it can't quite tell you when it gives you an array of the stuff what that stuff is. So it defaults to an array of objects, which is basically anything. And so you have to cast it back into a string if you want to actually use those things as strings. Okay, that's just one of those weirdness things. We don't really need to use toArray very often, but sometimes you want to take everything out of your bag and put it into an array so you can process it like an array.
The bag into an array.
Yeah, it converts all the stuff into an array. But it's an array of objects, not an array of whatever the T was. So when you use a bag to store many instances of something, you're going to use the generic type designation. If you need a bag of words, you say bag of string words, I guess it's a bag of strings, equals a new bag of string. If you want a bag of purchased items, you could say bag of item, purchase equals new bag of item. Okay, that's the syntax for doing that. Okay. Here's an example of some code, kind of like our grocery checkout thing, only now we're using a bag of item. Okay. So we made bag of item shopping cart equals a new bag. Instead of an array, it's now a bag. Okay. And let's just say we're doing 4 items from the shopper. We print, what is your next item? Again, we say item, next item equals new item of keyboard. Again, we're going to read it from the keyboard just like we showed you in the lab thing. And then we say, instead of that line that, added it to the array like we just did, you would say, instead of that, you would say shopping cart dot add next item. Isn't that a lot easier to think about? Let the bag figure out where it goes, and just add it to the shopping cart. Add it to the bag. And then the total cost plus next item back that price. Then, if you want to print out all the items in your shopping cart, this is what Christian was just saying. While not shopping cart dot is empty. What does that mean? While my shopping cart is not empty, right? Print shopping cart dot remove. Remove an item from the shopping cart and tell me what it is. Okay. So it's going to empty out the shopping cart and print all those things to the screen. Okay. Probably not too unlike what Amazon does whenever you buy something on Amazon and then you go to checkout, right? Making a software object to keep track of all those purchases. the shopping cart concept was patented by Amazon for e-commerce, and now look where they are. Okay, so that's how that works. So just a little quick question and answer session. A Java signature for the add method based on the previous UML diagram. These are kind of stupid questions, so we're going to go through these kind of fast. What was that? Oh, Boolean add T new entry. Suppose a bag represents an empty bag that has a finite capacity. These are not stupid questions, but they take a long time, and I want us to get coding as fast as possible. Suppose a bag represents an empty bag. Some pseudocode to add and user supplies strings to the bag until it becomes full. If you want to add like a string to the bag until it gets full, you say like in a do loop, entry is a new string, and then a bag dot add entry, and then it says while not a bag is full. However, remember what there was something interesting about the add method that it does? It returns, what does the add method return again? Boolean, right? So another way to actually do this, instead of adding something while the bag is not full, you could say while a bag dot add entry right in here, and if it's full, if it can be added, it'll return true, so you can then get another entry, right? But if it said false, you can't get any more stuff to put in it. That's another way to do it. But actually, now thinking of it, that's probably not as good. This is better because it's only going to let you add another item if the bag is still full. I mean, if the bag is still not full. Yeah. What's this deal with having two remove methods? Can we do that? Yeah, that's an example of overloading. Overloaded methods are methods that have the same name, but they have different parameters. So there's one that takes the entry that you want to remove, and there's one that doesn't take anything. So the compiler can tell those apart. Given the full bag, write some pseudocode that removes and displays all of the strings in the bag. While not a bag is empty, entry equals a bag dot remove. I think we're pretty much. Oh, what if you want to know how many times the word hello occurs in the bag? Well, you could say it occurs a bag dot get frequency of hello times. That's going to tell you how many times that thing is in the bag. Okay. All of these objects are kind of like this vending machines. They're these complicated apparatuses that have buttons on them, and each button is like a method, what you actually want to do to that vending machine, so it works for you. You press the add button, now you can add something to it. You press the remove button, now you can remove something out of it. Right? We don't really care how that vending machine is constructed inside, unless you're trying to break into it, right? You just know that if you press the button, you get a bar of candy. Okay, that's how these objects should be thought of. And then the last slide is the Java collections class. So we're using a homemade bag class by our textbook author for this lab. But there is a regular Java utility class called set, which is kind of like a bag, except that you can't put duplicates in it. Part of this class is also just to let you know what the tools are out there. But because it's in the Java util library, it's really easy to use. You can make a set of stuff anytime that you want. It has very similar types of methods, but it has objects, not generic types. So you have to put your stuff is stored as objects, which is a little bit weird. All right, we're going to hold off now. Let's get started and do some coding. And then I'll come back after our coding exercise, and we'll talk about inheritance, and then we're going to do some of these inheritance exercises.
The slides online,
Mm-hmm.
there is no checkpoint 1. So checkpoint 2 on both the slides.
I have to repost the PDF. Thank you. I often do all kinds of great work, and then I end up not putting it on my website, and I show up to class, and I'm like, fuck. Okay. So, have you all brought up Eclipse yet? Okay. Let's do a little thing with Eclipse. Now, Eclipse is on your system. I think if you open up, is it all programs? How do you guys get to Eclipse? Sorry? just type Eclipse under search, okay, and then open up Eclipse. Takes a little bit to load. Eclipse is a big monster of a granddaddy of software development engine, so it's really, really powerful.
With Java, C++, C#,
Yeah, it doesn't just do Java either. It
Python.
does a bunch of other languages for you as well. So if you like Eclipse, you can use this as your primary software development tool for any language that you happen to work in. I want to show you a couple things. One of them is the website. If you ever kind of get stuck on the website, there are some notes I've got as a link under here under resources. And you click on that, and it actually gives you some instructions if you're kind of unsure how to import some code into Eclipse. So what happens with Eclipse is when it opens up, it likes to put all of your code in one folder called the workspace. All of your projects, it wants to put them all in one place. Okay? And it asks you when it loads, do you want to use the default workspace of blah, 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 right? And you might have said yes, probably you said yes, it's okay. So what you can do, though, if you don't like where it goes, because I think that's on your C drive somewhere. So that means if you work and you do some coding on that computer, Nick, and you come back next class, you got to sit right at that computer again. If someone else is sitting there, you can't get to your code. So you want to change, you probably want to change your workspace so it points to your U drive. Okay, and so the way you do that, did everybody get Eclipse up? Okay, is anyone having any problems getting Eclipse up? Okay, so the way you do that is you say File, switch workspace, and then say Other. And then Browse. Now you should be able to browse under Computer, and you should find your U drive. Do you all see that? Let me know if you do. Yeah, okay. Because I don't have the same setup as you guys. So then point to your U drive. You might even open the U drive. You might create a new folder called CSIS10B or something, or Workspace, yeah. So it's not all going to be in that thing. So, yeah, question? Sorry. Did it work? Okay, so close the welcome screen.
Yeah, but you,
Switching workspace.
I mean, I could have saved it there, but I wanted to see what
Other
you drive.
history
So clicking on you.
No, then it's lecture. First lecture.
Okay, but you, that's share. Is that the personal?
I don't know.
He says, yeah, so I'm clicking on
Make new
that.
folder. Yeah, just click on Make New Folder and call it Eclipse. There you go. That's what you want to call it. Eclipse. Okay. Then all your stuff is going to appear in that Eclipse. Oh yeah, you got to log in. Not you. Anybody else? Yeah, I did that. Don't show me something way off in the future. I don't forget because we did the same thing. Okay, you all got your thing pointed to your workspace, pointed to the right place?
It should be. I just did it.
Good. 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 No worries. It's just we're just getting started, so you can always fix that later. So I'm going to use the workspace. I'm fine with that. And cancel. Okay, and we're going to do we'll make one quick project, a little Hello World project. So I need you all to focus up here, and then we'll actually import our lab folder so that you can do the lab 2 with that. Okay. Now I've noodled around enough with this. I can usually stumble through it. I might not be exactly perfect, but what you do when you want to make a new project, you say File, New, and you say I think you say Java project. Unfortunately, I should have practiced this beforehand, but I didn't. Let's just call this Hello World. Oh, I already have a project with this name already, so I'm going to call this Hello. Now, according to my notes, in the project layout, you want to choose create separate folders for source and class files. I think that helps when you export things. But it's already checked by default. You see where it says create separate folders for source and class files. Okay? And I'm going back to my notes here. The next step, then click Finish. Okay? You'll see on the left a folder there. All of your projects for the whole class will be appearing down that little window there, right? They're all going to appear there. You just kind of scroll down whatever project you're going to work on, and you're going to open it and work on it. And typically, see right now, I have two projects that are open. This thing called Grid World and this Hello project are both open. And I might want to, sorry? Oh, and Calculator too. So what you can do is you can do, actually I think if you right click on it, you can say close unrelated projects. You probably don't have any unrelated projects because it's the first time. But you can close all unrelated projects and they close. So the only open one is the one you're working on right now called Hello. But you only have one, so that's okay. And then we're just going to say file, let me see, right click, sorry, and let's say new class. Are you with me so far? Okay, so we're going to right click the Hello folder and say new class. And let's call this class Hello World again. And notice there's which method stubs would you like to create? If this is a class that you want to actually have a main method in it, it will already make a method stub for you called public static void main. If you're inheriting stuff, you can play around with inheriting stuff from the superclass, all kinds of neat stuff like that. Okay, but I think that's all we need to do, so click Finish after that. Okay, and there is your class Hello with the main method. And now all we're going to do is we're going to say system out print line Hello World. The other thing about Eclipse is when you type in one quotation mark, it gives you two. It automatically gives you a closed quote, so you don't forget about it. So, and then you start writing the string, but don't do another closed quote because you don't have to in Eclipse. It takes a while to get used to it. If you do an open parentheses, it automatically gives you the closed parentheses. Yeah. Don't put a space in the name. Yeah. And once you do that, to run the program, all you do is you hit that green triangle button up there at the top. You see that, the run button? And the console output is going to appear right there down below.
You want it like 2J, you can press double click in Hello Java, and it's like, you go to the compiler.
Say again?
Double click Hello Java.
Hello what?
Dot Java.
Oh yeah, this one? Hello.java?
Yeah, double click, and it's like 2J.
Oh, and then when you run it, it pops it up?
Yeah.
Oh, I never knew that. Oh, very cool. How do you undo that?
Double click.
Double click it again? Oh, thank you, Pablo. Yeah, that's really nice. See, I learned so much from my students. That's why I never prepare. Did you all see that? You want to see that again?
Yeah.
See, the default Eclipse is it's going to have your code embedded in the whole console thing here. And then when you run it, it shows the output at the bottom. But if you like it to be a separate, like BlueJ, where it has a separate screen, and then another screen pops up when you run it. You just double click on hello.java right at the top here of that file, and it changes it to something like that. Then when you run it, the console screen pops open for you, so it hides a lot of stuff that you don't need to see when you're running. And if you don't like that, you can go back just by double clicking on the.
Just leave that.
Just double click and it goes away back to normal.
How do you right here?
The green circle with the white button in it, the white triangle in it.
It comes up with editor does not contain a main type.
Well, you didn't check, or you must have checked about you don't have a main method. Oh, yeah, you do.
It's different because self click and you can not work.
I didn't catch that bit. So it'll pop up down here? Because it's not like pop up over here, but it's like it'll pop up down here. If you're heading there.
I've always ended myself.
Yeah, how much is this? Like $100. Clever. You get it cheaper that way, right?
Yeah, very.
How much was it? 30 bucks. Wow. Did you have to go to Europe to get it? That would cost a little more. But if you're there anyway, maybe we should always plan a European business trip before your classes start. Okay, so now we're going to import our lab, okay? So everybody, we're going to follow me along. This is a little bit of a few steps, okay? So we're going to download and extract the lab folder, which is a zip file, and then we're going to import that into Eclipse, okay? Or if you just want to work in BlueJ, you can do that too. It doesn't matter to me. Okay, so you ready? So we're going to go to the website. And you're going to grab the download link under Lab 2. Click on that. And open it. Okay. Highlight it, and then click Extract. And just put it like on your desktop or something. Or your U drive, yeah, put it on your U drive. Then you can work on it in either BlueJ or Eclipse. So if you open up the Lab 2 folder, you will see it has a Lab 2A and a Lab 2B. Today is 2A, and Wednesday is 2B. Anybody stuck or anything? Any questions? Okay, so now we're going to go and import that into Eclipse. Import will just go vacuum that up, and now it'll make its own version into its own workspace with all the code from that folder. Okay, that's what we're going to do. And I have to look at my notes for that again. So the notes say, let's see. So let's make a new project in Eclipse. So okay. So you ready? So we're going to say File, New, Java. New Java. Oh, you can?
Yeah. Import it. You can import it. You import there. You have to import when you click File.
Right click down.
File.
Import.
Import. See, you guys are so way beyond me. Import.
Then you have existing project into workspace.
Existing project into Workspace. Okay. Next, select root directory. Okay, so we'll browse, and let's go to the. Are you following me? Okay, is everyone following?
I couldn't find the existing project.
Yeah, you know there is. Did it not work for you? So you know, because we don't have an Eclipse project just yet. That was probably why the complaint is, right? I think because it's a BlueJ project file, we have to actually make the project first. Did it work for you, Jakob? Oh, it did? Okay. Well, let's try it. browse, desktop, find wherever you did your Lab 2 folder, and open that up, and click on Lab 2A, and say, OK. No? What do I do?
Oh, maybe
Because you have to create it first, and after that,
I got to create the project first, right?
don't pop up.
Thanks a lot, you guys.
Just drag the folder.
File.
Lab 2A, just drag it straight in. Straight in, it's right there.
All right. If this doesn't work, you're going to get penalized, though.
Well, you could show the.
OK, I'm going
the
to
way
grab
you
Lab
could show
2, hover over
Drag
Eclipse,
it,
and where do you go here?
Put it in source.
But no, I need to make a new project. I can't put it in source yet because I don't have a project yet.
Yeah.
So you got to make a new project folder. Guys, quit yelling out instructions to me.
You can create
Yeah,
it.
do
So
it.
file, new. Listen to the old grandpa and do it the way he says. New Java project. And the project is going to be called Lab 2A. Just do a separate one for Lab 2A and Lab 2B because they're going to be different folders. And then say finish. Okay. Then say open the project, right click source. That's what you do. Okay, this is what I like to do. Because you want to make sure it goes in the right place. It's easy for stuff to get out of place. Open up the project. You see there's a SRC folder. Right click on that and then say import. Okay. And then it says, oh yeah, and then you got to choose open general and then click file system. So where's general? There it is. General is open. Click on file system and then next, because we're importing it from the file system. From the directory, we're going to browse. Now we're going to find the Lab 2A folder. Lab 2, Lab 2A, and oh yeah, then you got to select all. Where's that? There we go. Select all. Like it's going to grab all the files, and then say finish. And now we've activated all it. Now, yeah, maybe you can drag it in there once you've got the source folder. You can probably just drag the Lab 2 folder in there. Is that how you guys did it?
You can do it, copy and paste it.
Cool. The folder?
No, you make Control C, Control V.
You mean on the folder? You can copy the folder and then paste the folder in there, right? Yeah. Let's do Lab 2B at the same time. So make a new Java project for Lab 2B.
So when we import we're importing. Oh, we're doing 2 only. Okay.
And then we'll try copying the Lab 2B folder and pasting that into the source folder of Lab 2B. No, that didn't work either. Hey, let me tell you something. If you notice, I just tried the copy paste thing. Maybe I'll try copying and paste it up.
I'm getting it says there are no resources currently selected for import, but I don't know why because we have to select them all. Select them and then finish.
If you do it a different way, let me tell you, there's one thing that's really tricky about Eclipse is that when you want to actually export the jar file to turn it into my uploader, did you learn about this? It'll sometimes, if you have it in the wrong place, all of your code will be like in a subfolder, and my extractor doesn't get it that way. It doesn't search through all your subfolders to find your code. It expects your code to be like inside the root folder, and you have the source code in it. So when it comes time to exporting, if you do it a different way, it may not work right for you. That's one of the tricky things, and then you can't turn in your code right. So that's why these steps I proved out last year. I think they should actually work okay for us. And if you notice, what we've got is the code is appearing inside the source folder of the project.
And then just double import package.
Okay, but we're
How come? You mean to run it from there?
I don't know. I'm not doing that.
Yeah, you could run it from BlueJ right in there too.
But will it?
Yeah, you could actually edit in BlueJ or in Eclipse. You've got a BlueJ project folder. Eclipse is fine. You can just make changes in BlueJ. If you don't like BlueJ, go to Eclipse. If you don't like Eclipse, go back to BlueJ. It can be helpful to have two compilers looking at your code. If you get a weird error message, sometimes you can get that same error message in another compiler, and it might make more sense to you.
Lab 2A was an error because back is not a type.
Because what?
A back is not a class.
Oh, wait a minute.
You have to open the package.
How do I do that? What?
Yeah.
The default package?
Yeah, that's the package.
Oh, there we go.
That's the important thing.
But, see, the bag has been pre-compiled.
If you open that, the error is at the last two lines.
So maybe this won't work with Eclipse.
You could import bag as a library.
How do I do that?
So you right-click properties of Lab 2A.
Library.
Right click. Okay, Lab 2A properties.
Down, 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 down.
All the way up. And then under
Java
Java
build
build path. And then if it's,
So how do I add? It's not a jar though.
you could jar it. That might work.
You can even add
There's a class.
folder.
It's not a folder. You know what? I think we're going to be stuck in BlueJ today, just because what I did is I provided pre-compiled code for the bag class because I don't want you to see the source code. We're going to be developing that. So it looks like Eclipse is not happy with that. It doesn't like it. You need to sort of import it a different way. Maybe we'll figure out another way. But let's go just leave it in the Eclipse folder, and you can bring up BlueJ right here, and let's just work in BlueJ today.
Can't we just copy it over and not look at it?
No. Normally, you would import the. Normally, like if it's a Java utility class, you just import the bag class, and you have all that code. It's a similar thing. It's just I didn't want to show you this thing because we're going to be making it later, and I don't want you to have all that code. So, I'll look into it. If not, maybe we'll just start an Eclipse maybe after the first test, and we'll just use BlueJ for this because we want to use these pre-compiled things. If that's easier.
Is the class blank to start out with?
Is it what?
Like if you go into BlueJ, the class bag is blank.
It says no source, but if you see there's a file in the folder called bag.class, that's the compiled bag class. So it's already there. So I'm actually going to just close down Eclipse and go just back to the folder that I extracted. Sorry about that, y'all. Maybe I'll have a better answer for you next time. And open up the Lab 2A folder. That was a waste of time. I don't have a lot of that to waste.
We learned the wrong way to do it.
You learned the wrong way to. You learned that my clever idea is not going to work, but it works in BlueJ, which is nice. And then open up the Lab 2A folder. Okay, back to friendly BlueJ. And what I'd like you to do is put a slash in front of the line that says demo 1. Now this is actually, remember I told you if you stuck a giraffe in your bag that could be bad? It is possible when you, Java's generic mechanism is actually less rigorous than C++'s. And with Java, you can compile this right now. See what I did is I didn't actually indicate what data type the bag should be made of. And if you don't specify the data type, then it makes it of the object class. And an object is, through inheritance, it's the ancestor of all classes in Java. So you can actually store anything you want in the bag. So you can see what I've done is I'm sticking, it actually gives you just a warning. You see that warning there? Java uses unchecked or unsafe operations, lab2a.java. And it's that warning is kind of cryptic, but what that means is you messed up how you're specifying the generic type for the class. If you see this in your program, you should figure out where that happens. Unfortunately, it doesn't tell you the line number that that's happening. What kind of a crazy, and I think Eclipse is the same way. They don't like to tell you the line number that it's noticing this unsafe operation. But the problem is we didn't actually tell it which type. And we'll fix it in a moment, but I just want to tell you, you can always ignore that warning, and you could actually run it. And notice I'm adding an apple, a carrot, the double value of 3.45, and John F. Kennedy as a person, okay, to a bag. And the point is, let's see what happens if we run it now. So we compile it. We just go past that. That's just a warning. It lets you go on. And now let's run lab 2A. Select the main method. And it says, person at blah, 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 blah. That's the, it's trying to print out John F. Kennedy, but there's no toString method for the person class. It prints out 3.45. It works okay. So you can actually do that if you want. But for most of the problems, that's not what you want.
This is right.
Yeah, if you made a toString method for the person class, it would actually, you could actually print out John F. Kennedy there.
This is working because we did not specify the type for the bag.
Right. So when you get those warnings, though, that's a sign that you messed up somewhere. Even though your program will still run, you should figure out where that warning is coming from and make it go away. There's always a place that's happening. You just have to find it. It's just not easy. So where is the problem in our case? Well, it's pretty easy because it's a small program. We're supposed to say bag of string equals B equals new bag of string. Okay, just like that. And now, this is what happens. See, the compiler says, oh, wait a minute. You just tried to put a double in that bag of string. That's good. Okay? Because we don't want to accidentally put something that's not supposed to be in there. It's easy to get mixed up. So this is...
Why did people double quotes?
Say that again, Chris?
Why exactly didn't it pop up?
Because we didn't have the word string here, restricting the data type for the bag.
Okay.
Okay, it was blank, which meant it defaults to object, and an object can store anything.
But if we put double quotes, it will take it as a string, right?
Sorry, double quotes?
Oh,
You mean the angle brackets?
no.
Oh yeah, yeah. If you want to store 3.45, still you could turn it into a string, put it in quotes, and that'll be okay. But then you'll get an error for trying to put a person called John F. Kennedy in there. Of course, you can put the string John F. Kennedy, but you can't put him as a person object. Yeah?
So you can't store anything in the bag if you don't specify it?
Yeah. You could put a whole array in there. For one item in the bag could be an entire array. So it's, all kinds of crazy things can happen.
Like different arrays in one bag.
Yeah. Yeah. It could be really mixed up.
It's really big.
Yeah. Of course, from the bag's point of view, it's only a reference to where the array is stored somewhere else. But that's what the thing you can do. So so we're gonna that's basically it for demo 1. Let's now get rid of that slash, so you understand, I think, why the generics are useful, and then put the slash by problem 1. And for the rest of the lab, I think you're going to leave problem 1 activated, then you're going to do problem 2. And then problem 3 using inheritance. We'll get to that later. Okay, so just do problem 1 and problem 2. Question?
I got it to import the class.
Oh, good.
So
Show me after class. Okay. And what I'd like you again do is work with a partner or two. You guys want to take a break, that's fine. I'll let you guys decide when to take a break on your own.
Oh, did you say? Well, it doesn't matter. I can type. I like typing.
I don't know. I don't have feature in my.
So we could either type it. Get on the board. been typing by any since. So okay, so
Anything you want. I don't know.
So you have a bunch of individual
Oh,
arrays
okay.
and different types of objects.
No problem.
but we have
No, just
we
make
have
a bag
this
of
on
array
this
though. You
website.
can't put array in square brackets.
It's yeah,
Put an array with it.
well, it should be there.
Yeah, probably right next to the, instead of the download, like if you click on the left.
You have two.
it's over the right.
Yeah, I just wanted to. Okay, yeah, it's there. Okay, so I can't remember to keep it rid of this because it was complaining.
You
I
can.
said didn't delete
I mean,
that.
this
what you do
is
is
an
you just-
integer.
You just remove the slash so that it ignore it. Because for this one you put quotations right, which turned it into a string, but that one just pointed this out as a comma because this
Yeah.
is a string, it's a person.
When you put this, you can get in as a hash into the bag, everything.
Everything.
But it's crazy. I mean, you can put there an array and a string and an int, and you don't know in which position you add something.
Okay.
And here, in this bag, you can only add strings.
But I just don't remember. Did he comment that out or did he?
No,
delete
there's
it?
a quote.
Yeah, you put quotations on that, and then that would turn that into a string.
Oh, like this?
Yeah.
Okay,
Now,
yeah, that's
that integer
But
will
then
come.
he said that if you point out that that would be the next column, you still get an error message.
Now,
Oh,
new
at the-
person, if
Because
you take new person, you delete it, it's okay now.
So just delete this.
Oh, I mean,
No, you
You
just
can
delete
delete
that
this.
part and then the second. And isn't that just a string itself?
They tried to declare
one more, like this is
this.
great.
Yes.
There is a
No, you don't need to do it.
Yeah.
array.
Okay. I still need
Put it on
it.
semicolon.
So it looks like the first thing we have to do create a bag object, my bag, add the strings, soup,
Okay, the first
Very
thing.
easy. You do some bag, my bag equals new bag, and then parentheses string, right?
No, you forget the generics.
Let's do
That's what I'm saying, like
Okay.
yeah, parentheses string.
It's bag, generic string, my bag, equal.
Generic.
Just,
angle brackets.
Oh, I gotcha.
I'm sorry.
No, I gotcha. Same thing, yeah. I was wrong anyway. I was using
Here,
parentheses.
here. But you have to this one.
So the first line is
Spain,
you can say bag,
generic.
angle bracket,
I mean, I think here is
string.
Okay, cool.
The name of the bag is called
Oh, no, I was
so
still
it's
wrong.
basically
My bag.
this syntax.
Yeah, you have to copy that.
Okay.
Right, type it, type it.
Yeah, like type it because for me it's
Type it, because if type, you learn.
yeah. Okay, so this is
Don't read it.
bad object.
Don't read.
Okay.
Okay.
So that creates your bag object.
I want to call it my bag, right?
And then we're going to add apple soup, apple pear beet soup.
And it's equals. And that's going to be a new bag.
Oh, yeah, come on.
Yeah. And then that's when you use the carrots.
Almost.
And you might want to just copy the add statement over and over again and just change the stuff inside it.
Do you need to do that?
Yeah,
You have
to
to,
see.
you have to specify. You have to specify what are you going to do.
On both sides?
Mm-hmm.
Because here you declare the new object, but here is the type of it.
It seems like it's redundant.
Yeah, it
This-
does.
this-
See, look, wait, let me see the notes. Look.
No, it's not redundant.
She said like a bag of words.
Oh yeah, you forget this.
Yeah, because
That's
it's the size.
like that was a bag of words. So,
Here, it's you're saying that my bag is a bag string, and now you're saying my bag is a new bag from string.
Yeah, but why can't you just say, I want to create a new bag that's my bag, that is a bag of strings?
Okay, then why do you have to make string equal new string? Or for example, int array equals new int array template.
Oh, I see. So you're saying that you're using that because you're defining it to be the default state.
You're saying that this my bag is going to be a bag of
String.
string.
It's going to refer to a bag.
Yeah.
So my bag is, when you do that, it means you've got a variable that can refer to a bag of string.
Okay.
This goes ahead and makes that new object in memory, and then gives you the address for it and stores it in my bag.
It's like, because I mean, why do you need to say that it's what do you need to string before you even create it?
Why do you need to say string here?
Yeah. Oh no, like why
Okay.
there? That's why I don't get.
Because that's restricting this variable to only refer to bags of string.
But don't you saying that right there when you're saying that
No,
it's a
this
bag?
is making a new bag of string. This is saying my bag will henceforth and forever only be able to refer to bags of string.
Oh, I see. So
Yeah,
it's,
like
it's
in
putting
memory.
it's putting the restriction.
Putting a restriction on that reference variable itself. So you can't refer to a bag of doubles or a bag of persons. You would have to only refer to bags of string. Then this goes ahead and makes a new bag of string.
So you're telling this variable it's referring only to here, to this memory.
So for 1A, just to kind of get you started, this is actually how that works. Okay, and in fact, I think I'm gonna kind of move you all through this so that it's not because time is kind of short, and I kind of think these labs are good just to kind of get the exposure to it, and then you'll get to try this on the homework because you're going to have to use the bag on the homework problems. So what I've done here is I've just made bag of string my bag, and there was a good discussion here right next to me. This part is creating this variable my bag, and it's saying that it will only ever be able to refer to bags of string. That's what that says. This is going off and declaring and making it an instance of a new bag object. The new operator tells you I'm going to go make a new bag object. It declares the memory, it creates the object, initializes all the variables, and then it returns the address of where it made that thing. And it stores it in this my bag variable.
So do you have to do that because of different size restraints for the strings versus the primitives? Like would it just?
You mean this?
Yeah, like would it just store primitives in it if it would it just store the primitives in the bag rather than references or the addresses?
It can't. It's restricted to only work with the generic thing. You can only have classes there. And if you don't specify it, it's going to default the class to object, which is another class. You can never get a primitive really to be stored in there. If you try to put a primitive in there, you can make a bag of capital INTEGER.
So,
and that will actually be an object that holds an integer primitive inside.
so if you left the bag with the
Zero
caret empty,
position
it would just
has
make a
zero.
bag
At one,
that could just contain any objects?
No, you have to leave. You have to actually not have carets there at all.
Okay, so yeah. So why is it better to restrict it so that you can only have strings when you're creating?
Because when things get really complicated, you want to know if you accidentally stuck something in there that you weren't supposed to.
Okay, so it's like
That-
a dummy check for later on.
Here's the deal. That whole thing about generics is it turns what would be a runtime error into a compile error. And that means you find them a lot sooner. It's a lot harder to find runtime errors than compile errors.
Okay.
It takes longer. Yeah. Mhm.
Sorry for being the dense.
No, I wish I had said that earlier. Thank you. I'll bring that up again.
It's a function of the method.
So for B, what you can do is you could ask the question, this is actually, you're trying to check to see if my bag is full. You can say, is my bag full? And then you can just say, right after that, you can say plus my bag dot is full. Right inside the print statement. And like that, this is how you're going to do most of these for B, C, and D and all. And it's going to say either true or false here when it checks that. Okay. So So it says my bag contains all this, and if I say is my bag full, it says false. You see? We're just trying that out. Now, what if I want to say,
Create that method.
You don't use a
It's a methodology.
statement?
My
Yeah.
bad.
I'm sorry, what?
An if
Oh, well, yeah.
No, you don't need to because you're just going to print the output. You could do an if statement. You could use it. You would normally use this in an if statement, but I'm just trying to get you to just throw the method and see what it does. It just says false, which means it's not full. But you could put that in an if statement later, or there's a lot of ways of doing this, but it's a nice, convenient way just to do a quick check on to see how this thing is working. Just to print the result of the is full method out to the screen. And it says false. Now, if I want to know how many apples are in there, I would actually say system out print line number of apples in my bag, and then I would say my bag dot get frequency of
That method, you create that method,
apples.
right?
It's already there for us.
Really?
Sorry?
I mean,
What do you mean?
now when you said the bag, I read the Java API, and it says that the bag it's an implementation. That,
Okay, this is our contract. There's a get frequency of method for the bag class.
A bag doesn't exist like a class like array list or linked list or tree.
This is a homemade bag class provided by the author of our textbook.
But you can. I mean, if you create a bag, you have to program all the class, right?
It's all done.
Yeah, you did it, right?
No, the author did it.
But he had to do
I
it,
compiled it, and then I
Oh,
removed
yeah.
the
Oh,
Java
okay.
source code.
Because that doesn't exist as in the API.
Okay.
Java API. I mean,
Okay, look, you see this?
yeah.
That's the bag class when I remove the source code. It has the compiled
I know.
class file there. That's what we're using. And you can't
Okay,
see it.
okay.
They can't see it, but it's there in the folder.
Yeah.
Yeah.
I was talking because that method doesn't exist as tree set, linked list, and array list, and all that. That frequency.
It's non-standard. It's unique to the class, yeah. But
Yeah.
yeah. But that's okay. We know how to use it. We just read the documentation.
Okay.
Get frequency out. So,
yeah, right there. Yeah, frequency out.
say remove from my bag.
Then it'd be in parentheses,
So do you have to use the remove method twice?
Yes.
Since there are two soups.
Yeah.
So
Do a remove soup and then a remove soup.
And in order to prove it, just print the items of the bag again.
so
Yeah, or you can do the contains. You can check to see if it contains soup, and it should say false.
Oh,
will it
Quote
do that?
apple.
Okay. So it'll just compare the strings.
Because you're,
Okay.
it's an object, not a string.
Right, yeah.
It's a string that comes here. Yeah, but it's
It's a
this
pointer.
object, this object,
If we do remove
this one.
soup, is it going to remove both of them?
No, you have to do it twice.
So you just have to run it twice.
Uh-huh.
So would you do a loop that finds out how many times it's there, and then do it? So
If you want to, but just for now, we're doing
Just for
rules.
now?
Yeah, this is just getting familiar with it.
Sorry.
Yeah, they were good.
okay, good.
It's compiling. Oh. We might have gotten that
Oh,
right.
my back dot.
Oh yeah, because we got to specify what we're going to do
You are
this
not
to.
calling this method. It's just for this class.
Yeah, we're just saying like, oh, perform that.
Yeah, please.
Something.
Yeah.
So it's
Yeah. Yeah, otherwise it's hurt.
Compile and it's good.
I always forget the
It's like what you're going to do it, and what you want to do, what you're going to do to it.
Now how do you run this?
You go to that guy, and then work.
Oh.
Yeah. It makes no sense. I don't know what it is.
what's this
Number of apples. Okay.
It's my bag.
Sounds so far.
So.
No, we don't want to deal with that.
No.
Don't overcomplicate stuff.
No. Okay. I just have approach. Okay, next. My bag.
Okay, bam. There's one right there.
This is the method with that.
No, it contains
Just
here.
we just
these
need
are
a
the
line,
methods.
right?
Yeah, so like the method's already valid.
This,
Like we're just calling it up.
this the class. This is the class. Here, this is empty. This is empty. This one were the variable, and these are the methods. That the variables are empty because they are all private. Private. Sorry.
Your English is solid. You don't need to make any apologies.
Okay. Determine if it has contains a big
But
message.
Okay, I think we have to do an if
Yeah.
or a while do maybe. Or is it then?
you just
Well,
have,
if the bag
you don't have to.
contains a
So like
You have to make an if, of course.
yeah, so if
This is my bag.
my bag dot contains
Contains.
So which one is the contains?
and open parenthesis again. Because we gotta put in what it's gonna contain.
Okay, open parenthesis. Okay, that. Or does it need a spacer?
No, I don't use spaces at all.
Okay. Contains at least like this.
Yeah.
And close.
Yeah. Because we got that one.
Yeah, and that one. Okay, then.
So I need to come out right down here.
That one. It contains or something like that.
Yeah. Your bag's got a bean in it.
A bit. Or more. Now.
Yeah. Semicolon. So we don't need an else. We're good.
Compile.
Because otherwise, like,
Oh,
if
it's
else
okay.
it just won't do anything.
Okay.
All right. Let's take the beat out and make sure.
Yeah.
Remove both slips from my bag and from there. Okay, so
For which one?
that one is
Uh huh.
We started out with my bag again.
Yeah, you could just use clear, but do a while it's not empty, just do a remove. Just do a remove operation.
While they're
I'll remove one item. Just keep doing it as long as it's not empty.
Maybe.
Yeah.
But maybe this class, if you just pass remove soup, it removes both of them.
yeah, I meant to ask about that. Hey, Tom, on your
But
remove
because we don't know what it does.
on the remove method,
Yeah.
does it remove all instances of
It
the
helps
item,
to-
or does it just remove one?
No, it just removes once. You gotta call it twice.
Okay, cool.
Yep.
just say my bag got removed. And then
Could we do like a while my
Contains.
bag got
Or
while
I
my
will
bag
do
got
it like this
contains
because it's a good way, but we know that it's like soup. We can do it like this.
okay.
But
Well, whichever one
if
for
you
you
are
guys
doing
want.
like in a serious project or something, you have to make it.
Oh, so it looks like the default size is more like 30 or so.
This, it'll remove both.
No, this one is still
It's not
here.
10. I'm wrong about the
So
default
we
size.
need a while.
I
Like,
added,
we need a while.
I think so.
21.
I think
Took 21 tunas.
Okay, so you help me.
so while my bag.
Okay,
My bag
No,
contains.
you're right with the. Did we? Yeah, no, you're totally right.
oh, okay.
You can check to see if my bag doesn't. Go, does my bag contain soup? And then do my bag doesn't contain soup and see if it does after you remove those.
Never
Oh yeah, you
forget
figure
that.
form.
I
Yeah, because
always do it.
otherwise this guy needs to go up and just there.
I always
Okay,
do
you
it.
guys help me out.
Here, my bag
Yeah, so my bag.
contains.
And then open
Open
parentheses.
parentheses. this and close it. Close it.
Close it every time. Okay, did I do it?
Because I forget it and all this hard.
It'll save you time. Go back.
Did I have an extra one, don't I?
No, it's
No,
good.
so you
Oh yeah, okay.
for that one.
You have to make
It takes the word soup
Exactly.
while it contains. Oh yeah, because then it'll keep
my
going
bag
all
to
the way
make
through.
this one.
Then that needs to go inside.
And everything.
Then after that, on the outside of the loop, we should just write system.
Well, how do you know they're really gone? Check the frequency.
My bad, right? Yeah, so
Copy this one.
So then I
Copy
would
this
check
one.
the frequency by oxygen.
Trying to get efficient here.
write down outside of the loop.
Outside of it.
So we don't have to just do it over and over again.
Compile. Come on.
Okay, yeah, well, you know, for me, because I'm coming from work, I feel like.
Oh.
Alright.
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 Progress.
Alright. So, next. Write a while loop that adds tuna to the bag as long as the bag is not full. Okay. So that was like, I have to look at my notes.
No.
No.
Do while.
Just look at it right there.
No, you can make wild.
It's the same thing.
It's the same, yeah.
Like I said, just say while.
Give me 5, yeah.
Well, okay.
And then should we look for the
My
command?
bag
As long
full.
as it's
Yeah, we just do this full and put the
full. Is it like this?
put the
Not
the knot right there. So like, well, my knot bag is
full.
full.
And don't forget this. Okay.
Yeah, but where does the knot go?
Right in front of you. It's so confusing.
Yeah,
It makes
because
no
it's
sense.
like
Yeah,
in front of
it
it is
makes,
full.
yeah.
Just remember that it doesn't make sense, and you'll be able to remember.
Okay,
Now
so
you have to make
now.
my bag dot add equal to.
No, well, you see,
Ah, yeah, it's
inside,
there.
right?
Yeah, you're good. Yeah, you're
Yeah,
good.
you press enter. I didn't see that.
You did good. Okay. Okay, so
My
okay.
bag dot add full. Because you have to add a lot of tuna to the bag.
Okay, do we? I like to look at something while I'm talking.
Right. Use same with rice. We're gonna do that exact same
Oh,
thing.
okay.
Change
Add
soup
tuna.
to tuna.
Okay.
And that's all you have to do. Actually, that'll be
But
the
don't copy. It's easy. It's easy.
Okay.
This,
Okay.
this, and this.
For CS.
Okay. Add tuna. We have to put tuna. I mean, see, but I look at it first while I'm doing it, and then the second time I just do it.
Yeah.
Yeah, you have to make the object. What you're gonna do to it.
So is the default bag 25?
Oh, that's a good way to
I guess it's 25.
That's the only way I can.
So I have to change
I'll
my
do
clock.
the action and what it is.
Exactly.
Oh, this
Oh
could
no,
be
you have to make now this.
printed. Oh, to.
I kind of want. Yeah, I actually kind of want to see it.
Yeah, it's like yeah.
I want to
Because
see
then
it.
if it doesn't work, you can see.
The bag size of 10, right? So we should see like
Now-
most like 6 tunas.
What
Oh,
is it?
where is it? Or just what I should. Oh yeah, right. Okay.
Question?
So.
Go down to
No,
here.
man, yeah.
Like that. And go to this one.
Maybe we need to clear it out. Yeah, try to
If you
print.
close it, if you close it over every time, it'll relaunch every time.
Okay, now it's done.
Let's go down.
I want to say usually well not.
Yeah, okay.
Don't worry about
A lot of tuna.
Okay. That was totally
Yes.
Okay.
They are on
And
fire,
then we
man.
can clear to get rid of that. Or I don't know. We
You
should
can just close it, like it'll pop up every time.
Should we close it?
That's what I do.
Yeah. Okay.
That way I don't lose it.
Okay. And then
We're touching.
okay, same thing.
Okay.
Same thing as here,
Is that-
but changing. It's full, but it's removed. It is empty. It's not empty.
As long as
Good.
the
It's
bag
not
is
empty.
not-
Boom. It's not empty.
While
I'm sorry.
as long as the bag is not empty is full.
Well, not empty means it has at least one in it.
Yeah, yeah.
Yeah.
Okay.
So when I put like the knot in front of it, you can.
Okay, not my bag.
Yeah, like so saying it's
Is
not full
empty.
means that there's at least one. No, it's got room for at least one more.
Well, it's not empty.
Yeah.
Essentially, with this, no.
Yeah.
So you could just call my bag.
Yeah, but the fun thing is you can actually print out the items that are being removed, and you can say like my bag got removed because the remove method returns a reference to the object that it's removing. So you can show them all being removed like that. So the answer for G can look something like this.
It's not empty. Open, open, it's again like this.
Oh, yeah. Oh my God, yes.
It's getting late, I'm telling you, it's 'cause it's late.
I totally forgot that part, to be honest.
Yeah, me too.
Well, it's because I'm looking, sometimes you have to look. Okay, so it's not empty. We are going to,
My bag.
Hold on, yeah, there was a.
Remove.
faster.
And you pass.
And then go on and start doing problem 2 once you finish problem 1.
And make this.
And actually, here's the plan.
The first element.
Well, that's a trick, but let's do the regular
Oh,
first,
oh,
and then
this
do
is
the,
So,
perfect. I mean, it's like this.
I'm going to
And
start
every time you're
the
removing
final
one
lecture at 25 after.
but
No, that makes sense. I got you.
Y'all can hear
let's do the
me?
loop,
This
can we
is-
do
So
the
if
loop
you want to
also?
go on a
Just so
break,
we
This
can
isn't this
try.
right here.
Yeah.
You
This
gotta
is
go
it.
now.
He's just saying that you're always going to
Oh,
take out
that-
the first spot.
Whatever is at
Because-
0.
Yeah, like because if you take that out,
Oh,
everything
that's
slides back
great.
over. That way you know you're always going
So that is,
It's perfect.
yeah,
And you-
because otherwise.
And you stop making my bag without size and all that stuff. You make 0 and always remove the first one. Maybe you don't never get out out down the section and nothing like that. You always remove the first one. And this right is getting.
Okay, okay.
So that was the one where we could remove it and then probably use that to drive a display, right?
Huh?
We need to remove it and then display the item. Like, so it's like you remove one, you display it, and then you remove the next
Yeah,
item.
remove it and print them as long as the bag is not empty. So
I know it's not broken.
How did you reference that item that you just
So you remove it and you print the thing you remove, or you print it and remove it.
So it's like, this is what your bag contains item by item.
Yeah, how would you, because you already removed it at that point.
Yeah. Then you have
Yeah,
to
so
what I'm
like,
saying?
where are you referencing it?
you have to make this here.
But see, then
I remember we were
printing.
talking about this.
Oh, you're printing what's at index 0.
Yeah. And you have here.
The empty space, what is the empty space that you're putting in here?
That means that you're just making a blank line.
Oh, okay, okay. Yeah, but then you.
But I don't know why you're doing it.
Yeah, why are we putting this here? The print line blank space.
No, it's for print that what we are going to remove.
Yeah, so
But-
how do we do that? It's
Yeah.
whatever is at index 0.
I was thinking,
And
but
would it,
we don't
would,
have.
can't, won't it just be like my bag at 0 like this?
Because the bag, like after you remove it, the object at my bag 0 is going to be the item that wasn't.
And you know, it's not in any particular place.
Yeah, like, I remember.
See what I'm saying? So how do
We have to print that. Oh my God.
That was the
Yeah.
reason
It's like this.
between these two different remove variables, because like this one, you could use it to take it and be like, hey, you can display it, and then this one.
T is tight, right?
We have to print them.
Yeah, but see, are you printing what's left in the bag, or are you printing the thing that
I
you
think
just...
you're trying to print the thing that you're removing.
Yeah. Oh.
Yeah,
That-
see,
Because
you're
otherwise
printing what's
you're-
left in the bag.
Yeah.
Unless you guys can think of
Because-
anything else.
Because we don't have a get
See,
method.
can you put whatever is at 0? See, but that's the thing, because we don't know what's at 0 because it's thrown in there. See
Yeah,
what
like
I'm
that's
saying?
but that's a bag. Like you don't know, there's no order to it.
So how do we figure out, how do we print it, you just remove it.
Yeah, that's what I'm saying. I
It
know
was
there's a way to
never-
do it. It's like when you do it this way, it removes the address and like puts it somewhere else.
Yeah, see,
Or
maybe,
this one,
is there like what, mine that, remove that 0 and then put that thing into a variable and then print it? Yeah.
Hey Tom, we were
Yeah.
talking earlier in class about why we had the two different remove methods, and I remember this specific scenario came up when we were talking about it. Where you could take, you could use one of them to remove an item, and use that to drive an output on the screen. Like, so you could reference it after you've already removed it.
Well, you would. Here it is, right here.
Yeah, I didn't see that till just now.
So if you say my bag got removed, it will actually spit out. It'll return a reference to what it's removing, so you can print out what it removes as you're removing it.
Oh, okay.
So that'll
while-
cause an output and remove it at the same time.
Yeah, it'll remove it and it'll show you what it's removing.
Super cool.
Okay,
Yeah.
yeah, basically, yeah, that's basically removing. My bag got removed. That should just be removed. And then empty, take the 0.
It'll work still.
Yeah. It's the same because that takes one.
Okay, what we're specifying.
He's saying, oh, well, maybe not.
Okay, so now we're, oh,
Maybe we can do Jay. Yeah. It's too clever, right? Too clever for Blue Jay.
it has to catch up.
I'm picking up what you're putting down now. It's interesting.
Turn, up.
Alrighty.
Hold on, so is that the opposite of the exact opposite of where we put them in?
No, like
we put it
Okay.
on the apple pear.
Oh, yeah, look.
Huh. So it just started with the last time.
It's like a cute person, was it?
So in 5 minutes, I'm going to start the lecture again. So if you want to take a break,
I wonder how we get to do it the other way then, because that's what he was trying to do, was to display it more at the beginning, so that the first item you put in would be the first
Right,
item
so
you
there
took
needs to be
out.
a
I think in this example, you just
And that's
wanted
Oh, yeah, no, it
to.
doesn't matter. I'm just curious. Because
But
that's
that's what we're
do.
learning in this
It's gonna
class.
return,
That's the
it comes up
whole,
with
what the
public
class is about. So we're going to learn
Should we go with problem 2?
2, yeah. Okay, so,
public string,
it's right here.
two string.
Okay, object, 6
Public string with a capital S, return.
So here it is. Okay, can you remember?
STRING.
Okay, so,
Space, the name of the method is
I can't remember.
Bag, open parent, person, closed
just return,
Lowercase back.
you know,
Yeah.
just return,
Only one
Just a
person
second,
like
just
this.
a
very small, just like that, just return.
Just to, there we go.
They need curly braces.
Like this.
How did we write it up?
Java, it's really sensitive for
We,
lowercase
maybe do
and
lowercase.
uppercase.
Yeah, so just make it two string.
Remember,
In fact, you can just
bag
change
Yes, yes. Oh, uppercase.
and person too.
Oh, alright.
It's really sensitive
Bag's
for
gotta
that.
be
Oh, and person. Oh, yeah, see, I couldn't remember.
The first letter of class is
Equals
always
new, bad, whatever.
it's always uppercase.
Okay.
No, this has to say purchase.
So bag
Okay.
and person.
Anybody else want to sit and tell us what we're doing? Person. And then,
It's gonna be CS underscore club.
Underscore.
club
Equal
equals
of person.
person. Oh, person. Yes, I'm thinking like,
I was thinking in the parentheses earlier.
yeah.
What did you call me on it?
Parentheses. Yeah.
Yeah.
Parentheses. Okay.
So is the bag
the
class
person.
adding in
Cool.
formatting?
Perfect.
We did all this before, so.
The two string method in the back class is
It's
putting
perfect.
commas between all the
I
others.
think
Mix it up.
it's usually with
A
space
space.
because you have to know the difference.
That makes
Okay,
sense.
yeah, I like some good white space. Okay.
Yeah, like I'll
So
be cool with that.
okay, you guys.
So this one is just gonna be my bag.
Now it's like
Or no,
the
my
other.
bad, it's not my
No,
bag,
other.
it's gonna be CS
CS club. Yeah.
Yeah.
You can. This is difficult we can make like silly students. Yeah. We can make this a lot of technology.
Okay, so
Because we have to add this.
add the person.
Yeah, and
Like
then
Parentheses.
so not dot, but just parentheses. And then parenthesis or quotation marks there. Joe Frank, the man with two first names.
Oh
No
gosh.
problem.
Frank,
Frank.
same.
Okay. Go Frank.
Close
Okay,
parentheses,
close it.
semicolon.
And then, so it's
Enter.
insert
Copy
add
that whole
like
line
this, yeah.
and then just change the name.
Okay, and then how many of these?
1, 2, 3.
Lara, I'll mention. Lara?
Is Spanish?
Yeah. That last name is Spanish. Oh, and that name? First place?
So the adding person for the bag contents and then to write a two-string method for the person.
Okay.
I don't remember how to write two-string.
So that one would just be.
You remember, huh?
I have an idea. This is probably wrong. Couldn't you just do?
Then you're done.
It'd be just like this. So it's not like the people on the club are bag dot two string.
Okay, I'm going to start the lecture. So I know it's hard to rip people away when they're having so much fun. So you guys, hey, I'm going to have to kind of. What can I do? So stop programming and start listening again. Thank you. Stop programming and start listening again. Thank you. So we're gonna now go, and what we're gonna do is we're not gonna get through all of this. So the person class. How many people finished? You all finished problem 1. Did anyone not finish problem 1 yet? Okay, cool. So once you're finished with problem 1, what you can do is you can comment out the. You can remove that slash here in problem 1, then it goes away, and then you can activate the slash by problem 2. And problem 2 is doing a bag of persons. Okay, so that's nice, and everything's pretty straightforward here, except to create a new bag of persons. I'll let you guys do that. And I notice a lot of people already figured that out, and you're supposed to actually. It's being called CS Club. So this is now a bag of person object, right, etc. And to add, how would you add Joe Frank to this computer science club? Did you guys get that? Who got that? People got that, right? What'd you get? Dot add, and then you got to make a new person object, right? New person, and then Joe Frank. Okay. So that makes a new person object of Joe Frank, and then adds that person to the club. Okay. Then it says you're going to have to write a toString method for the person class, because when you print out the club, to print the bag contents, there's just going to be a system out print line. CS club members are, and then what? CS club. No. You don't say toString. Yes. It's automatic. When you put an object in a print statement, it automatically invokes the toString method. If there is a toString method, it'll invoke it. If there's not a toString method, you get a weird address thing. It says something something add something something. So that gives you that. But you never actually have to say toString explicitly. Not in the print statement. Sometimes you want to do the print toString because you want to get a print for some other reason. But yeah, that's the nice thing about the toString method. But since there is a toString for the bag class, but there isn't one for the person class. So we have to go to the person class and write it. And here's the place you do that. It's very easy. And Chris, it looked like you had a question there.
No, no, I'm good.
Okay, cool. You've always got good questions, so I want to pull those out when you can. So notice there's the person class is really kind of dumb, right? It's just a string. See, the person, what's a person? Well, it's just a name. Okay. Why didn't you just use a string? Well, you could have, but this is called a wrapper class. So person is kind of like a wrapper class around strings to make a string look like a person, because now there's a get name, a set name, you know, that kind of thing. But if you want to make a toString method, all you got to do, since it's very simple, you can just copy the get name method and call it toString. And now you got it. Easy as pie. Anyway, I'm expecting you to kind of noodle through problem 2 on your own. I think you have enough capability to do that. And I want to instead target the next part of the lecture, which is called Creating Classes from Other Classes, which is Appendix C in your book. Okay. And this is where all the stuff about inheritance is. And there's so much to cover, like, oh, it's overwhelming. But we're just going to do a really simple treatment of inheritance now. We'll bring in, I know James wanted to know about polymorphism. Tell him we'll cover polymorphism in a couple weeks. So we'll have a little bit of a here, a little bit there. Little by little, we'll get these things done. Because otherwise, it's just you choke on it. It's just so much stuff, you know. So the basic idea of making classes from other classes, there's actually a couple different ways of doing it. One way is called composition. And what I just showed you was an example of composition. A person class that just has a string inside it and makes that string kind of look like a person, we call that an adapter class. That's also called using composition. In other words, a person is composed of a string. Right? Person object is composed, the person class I just showed you shows that a person is composed of a single string representing the name, right? That's composition. Here's an example of a student object. A student object contains a string for the first name, a string for the last name, which is embedded inside a name object. You know, there's you can do many layers of embedding of these things. And then it has another string object for the ID. So a student has a name. A name has a first and a last name, which are string, right? A student has an ID. Composition is indicated when you have a sort of a has relationship. As opposed to inheritance, which is. But we use composition quite often. So, for instance, I just needed a quick class to show you something besides a string. So you can make a bag of something besides string. So I made a person class that just had a string inside it. That's kind of an adapter class for, you know, a person is an adapter class for a string to make it look like a person. So it has an instance of an existing class as a data field, and then it defines new methods needed for the new class. They show in the book, you can read about a nickname class that has a name inside it to hold the data. Well, actually, it is right here. Here's a name class, which has a first and a last name field, and constructors and methods to access and modify the fields of the name. The nickname class is an adapter of the name class because inside the nickname we've declared a field for nick, which is of type name. So it's actually a nickname is composed of a name object. Okay. And composition is where we're sort of nesting objects inside each other. It's really interesting in its own right, but it's not as powerful as inheritance in terms of software we're using. And this is showing Bob as a new nickname object, and we're setting nickname of Bob to Bob, and you can print his nickname if you want. It's another little exercise. Inheritance, though, is really it's kind of one of the crowning benefits of object-oriented programming. It allows you to reuse code and access all kinds of capabilities. When I made that little assessment program, which is another assessment you can kind of play around with for this week, I didn't want people to copy and paste their answers from one, like someone could email all their answers to their friends. So I was able to make my own version of a JText field in which I disabled the copy and the paste methods, because I could override those and put nothing inside them. So now you cannot copy out and you can't paste into that little text field window on there. And it was because of inheritance that let me do that. It was very neat. The idea of inheritance is that as you start writing objects, a lot of different objects, you notice that there's kind of a relationship between a lot of these things. They have a lot of common. A lot of them have a lot of common features. And inheritance indicates kind of like in a family tree where like vehicle is sort of like the ancestor of everything that comes below it. So below vehicle, you might have so up above you have sort of more general classes, and as you get deeper, you have more specific classes as you go deeper into this tree. So vehicle is the ancestor of below vehicle. Automobile can inherit everything from vehicle, but then it has a few more specifics added onto it. A wagon can import everything from vehicle with a few more specifics. And then the same thing with other subclasses of automobile and boat. You can have sailboats and powerboats, which are based on boat, but with a little more details. So you're actually kind of adding more specificity the farther you go down the tree. You know that you have an inheritance relationship if you can use an is to describe the relationship between the two classes. In other words, a powerboat is a boat, right, with a little extra details, right? A boat is a vehicle that goes on water, right? So it's a little more specific than just a vehicle. It's a vehicle that goes on water. That's a boat. But it's still an is relationship. And the amazing thing is, once you set up an inheritance relationship, you could make something like an array of vehicles. And we notice how, we normally, if you have an array of vehicles, you can only stick vehicle objects in there. But because a boat is a vehicle, you can legally put boats and wagons and automobiles inside an array of vehicle objects, okay, because they all satisfy certain core features. So here's another relationship between students. You could have college students, undergraduate, graduates, all that stuff. It just happens all over the place. There's a lot of information about what actually you can access when you have an inheritance relationship. And since most of our fields are defined as private, the derived class cannot access those fields directly, but has to use the accessor and modifier methods, the get and the set methods, to modify or read those fields. And that's actually considered a good idea, because otherwise, you can do things, you can mess with the ancestor class data that would be improper. There's a lot more to it. If you want to read a little bit more, there's an article I've linked to on here. I don't want to go too deep in it. And at this point, there's a couple things. One of them is you have to make a constructor for your derived class, and I think it always has to invoke the constructor for the parent class. So you have the word super, which means go ahead and build all the information for the superclass, and then you can add your specifics. This stuff is really hard to talk about. In fact, I'm almost thinking I should go straight to the lab, because then we'll actually, I can explain it while we're doing it. So let's do that. Let's go straight to the lab, and I'll explain more of this stuff while we're actually doing stuff. I think it will make more sense when you kind of see it in action as opposed to hearing it in terms of a lecture. So if you scroll down to part 3, no, you can leave. Well, yeah, mine isn't going to compile, so I'm going to comment out problem 2. And yeah, let's activate problem 3. And we saw there's a person class, and we made a toString method. And the equals method, I think there's a pattern for the equals method farther down here, by the way. So let me just show you. Here is the pattern for the equals method. For problem number 2, when it asks you to write an equals method for the person class, you can just look at this pattern. This is the pattern for a name, but you can just change that a few details. It's not going to be exactly the same, and make a check whether 2 person objects are equal. That'll be part of your assignment to make an equals method for the person class. I'm not going to do that right now, but you can kind of just see how that works generally. So, but the lab is asking us to here is the lab, and for problem 3, it says we can derive a student class from the person class because fill in the parts of the class indicated with stars, then test the student class by activating the driver found in the main method. Okay, so let's go to the student class. Okay, and what we're going to say is that in some sense, this is not the same student as is in the lecture slides. It's a very simple student. But we're going to say a student is a person, right, with an ID. You know, a person has a name. A student is a person with an ID. So we're going to actually use that relationship to kind of build a student from a person class. So to say that a student inherits from the person class, we have to say extends person right here, okay? And that means it inherits everything, all the code written for the person class. And here is the thing we're adding to. So we're adding a field for student objects. So inside a student, there's going to be a person automatically because we're inheriting all the stuff from a person class. And then we're adding a student number. Now, when you construct a, this is a no-arg constructor for a student. If we want to construct a student with no information, we have to invoke the constructor for the parent class. Now, you'd think, why don't you just say person? Well, I don't know. Seems like you should be able to. But instead, we use the keyword super. And this basically, this is actually fills in data for the person part of the object using no args. So it's actually going to give you the default value for whatever the person is. It's a blank name. That's all it's going to do. And that has to be the first line of your constructor. You have to say super on the very first line if you're going to do it. And usually you do it. And then we're just going to set the student number equal to 0. Okay. Now, the explicit constructor is the one that takes 2 fields. It has the initial name and the initial student number. How are we going to invoke the person constructor so that we give it the initial name? We're going to say super parentheses initial name. This is just going to, we're just passing this right up to the person constructor. Okay, and then we're going to say student number equals initial student number. Sorry that's so long. Type carefully. Okay. What about get student number? How are we going to do the get student number? Instead of returning 0, we're going to say what? We're going to say return student number. What about set student number? We're going to say student number equals new student number. Very simple. Now there's a driver here, and we're going to also need to make a toString method if we're going to print out a student in this driver. Okay? So let's make the toString method right here. So we're going to say public void, not void, public string toString. Now this has to return a string representation of the object. So we have to return, how do we get a string version of the person component of this class?
Start a number and the name of the person.
The what?
Name of the
Super. We could do super.toString and use the toString method for the super class. Right. Or we could do super.getName and just get the name.
You don't have to call super. You can just call the method of person. That super.
Say again? How would you say it?
I don't know the method of person, but
It's toString. Now I think if you say toString here, that might invoke the toString automatically of the person class because you're defining the toString for the student class. But I think to be safe, we're going to say super, and actually, no, I don't know.
I think that's what it said in the book, that if you do just toString, then it just brings up.
I think it's maybe just super.toString. And that'll give us the toString from the person part of the class. And then we're going to add to it the student number with a comma or something, or a space.
If it was like 2 layers deep, would that be super dot super?
No, but see, if the person was inheriting from something else, it would have its own super inside its toString method.
Oh, so the toString method would automatically.
It would just go up the chain, but it would do that all internally. See if that compiles.
You would have to be like super.
But if the person class inherits some other class, then do we have to, in this class, write toSuper?
No. If then the person would have its own super inside its toString method, so it would go up the chain that way. It's the same question, yes. Okay. Good. So now let's do the test driver here. Just sort of test these things and see if we can print out a student. We're assigning a student. We're using a NOR constructor. Yes?
person doesn't have a toString.
I just added one.
Oh.
Yeah. So make one real fast. I just did one while I was lecturing. I think you didn't see it. It's just like the getName method.
Return not super toString.
Uh-huh. Yep. Thank you.
No, he's right.
Now, if you notice, notice we're actually we're using setName to set the name of the student. Do you see a setName method in the student class? Yeah, do you see a setName in the student class?
Yes.
Where?
No.
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 And yet it compiled. Why did it compile? Because setName is in the person class, and by inheriting from the person class, we inherit all the methods that the person actually had defined. That's the amazing power of inheritance.
We are getting it just because it's public.
Yeah, if it was a private method, you wouldn't get that. Yeah.
Because of its ancestor,
Yeah.
it already has it ancestor.
Okay, so now we can compile and run it and just show that the class works. And now you can right-click the student and just run the test driver in the main method, and it makes Hermes Paris and Zeus Manasses. I know, I have fun making these names.
Definitely winning in the game of life.
Uh-huh. That's the driver inside the student class, just to try out a few things. Okay, questions? Okay, that's the basic concept. Now let me, now that you kind of have a sense of what it is, I think some of these things will make a little more sense. So let me go back to. So that's what this slide was. When you make a constructor for the student class, you have to call the base class constructor to initialize all its fields. Otherwise, it's not going to work. And when super is used, it must be the first action in a derived constructor definition, and it must not use the name of the constructor. So it's just the word super, not person. Right. Now, when a derived class defines a method with the same signature as in the base class, that's called overriding. And we just did that for the toString method. We overrode the toString method for the student class, so it works a bit differently than what this toString method does for the person class, because we have to show the ID number as well as the name, right? That's called overriding. It has to have the same signature as the base class. The method name is the same, the return type is the same, and the same number and types of parameters. And then if the derived class invokes that method, it will use the definition from the derived class. Are you all ready to listen to this? I know some people are actually doing something. Maybe it would be best to wait on that. You can stick around later if you have any questions. Or was there a specific question you had? Or okay. I just think it's better just to kind of keep on this, otherwise I'm going to lose you guys. And then if you want to actually, in the derived, if you want to invoke the parent version, you can actually say super in that method like we just did. So here's an example of we have a student class and a college student which is inheriting from the student, and the client class. Now it invokes the toString on a college student, which goes to the college student toString method, which it's invoking the super toString, which means it's invoking the toString method for its parent, the student class. Okay, it's this long chain of methods going up the ladder of this inheritance structure to do it. Now another way of defining a method is called overloading. And then when the derived method has the same name, but the name of the method is the same, but you've got a different return type or a different number of parameters or type of parameters, that's called overloading. And in that case, Java can tell those apart because they have different parameters. Well, however you use it is the one you're actually going to use. And I don't think I have a good example of that. But this thing is that an object of the derived class, the lower one, is an example of the parent class. So therefore, you refer to that with a similar variable. So, do you have a question?
I was going to say, wouldn't our toString that we wrote then be overloaded if it took the toString and added another variable to it with the student ID?
No, let me go back here because and this stuff is really important to kind of get straight because it's all about the signature. So here's the student, and it has a signature public string toString. That's all Java uses to figure out which method to use. And then if you look at the person one, it says public string. It's exactly the same signature. You see what I'm saying?
I gotcha.
That's how Java figures out which one you're trying to invoke. Since it's exactly the same, if you invoke toString on a student, it's going to use the student version of the toString.
So it can be considered as overriding
Kind of.
method?
Yeah, that's called overriding. That is called overriding. Yeah. And
So one more thing.
Mhm.
The signatures are same, it's called overriding.
yes. What was the other thing? That is, if the signatures are the same, that's called overriding. Okay? Good. Yes. If they're different, so suppose I actually had made a public a toString method that took some like intn. Okay. Now that's called overloading. It's a different signature. So, and you're going to use it differently, right? So I would have to say, my student dot toString of 5.
Yeah, totally off.
And then it knows which one to do. That's called overloading. Okay, got it? Good. Very important things, but very small, and we're not going to go too much farther than that. But the other cool thing, though, that I wanted to kind of say is that back in the lab, so now we've basically kind of got this thing down, and it compiles and all. If we go back to lab 2A, we can see that we have to define an equals method.
There's a mistake on there. There should be E on the last part of where it says A equals D.
Yeah, with A.
Oh, thank you, Dean. You're awesome. Okay, everybody, you see that? You see the under B for problem 3? It's checking to see if student A equals all these other things. That last D should be an E. Okay. And as you as you you know what the thing is, we made a club here of persons, and I commented out, but eventually you're going to have this both active at the same time. And you'll find if you make a club of persons, even though, you know, Java's really anal about this now, you should only be able to put persons into that bag, right? You with me? Looks like that, right? But because a student is a person, you should be able to add students A and B to the club. So now the club has persons and students in it. Okay? And you should be able to print them all out because they all have two string methods. And it'll print them all out as students or persons. Yeah. So, and that allows you to actually have a sort of a little bit more mixed type set of situation in your bag because they're all related to the same base class.
But right now the bag will only have the objects of the person class. Can't have the objects of
No,
the student.
part C. If you keep problem 2 active, you can now add students A and B to your club. Can you do it? So you should be able to say CS club.add A, right? And that's going to add student A to the club. If it compiles, and it should, actually, let me just see. Well, I've got these equals. We haven't defined the equals method yet. Let me just comment this out. It compiles. It's okay with that. The generic is okay because a student is a person, right? It's going to let that happen because they share a lot of the same features.
So that bag will let persons and any subcategories of persons in it?
Yeah. And that's why you should read the Appendix C to learn more about what I just said, because it's really, there's a lot more to it, and I can't go on any further.
Can I see what you did?
Yeah, sure.
The declaration, let's see, maybe I already have it back.
Of the Computer Science Club.
Yeah.
Just like that. Mm-hmm. Yep. Good. Now let me just, there's just a couple really important things to be sure. I know you want to run off, and I'll show it to you after I'm done lecturing. Let me just, I just got to cover a couple of things. There's a couple more things really important about inheritance. Okay, so just, you guys hold off, don't even look at your code. All eyes up here. This is just the important things. I just want to, just chill. Don't look at your code. It's okay, it'll be fine. We'll get it later. But inheritance, you see, there's an implicit inheritance always with any class we create, that we always inherit everything from the class object. Capital O. It's the ancestor. It's the granddaddy of any class we create. Even if we don't say extends, we're automatically inheriting everything from object. That's why we were able to print stuff out without writing our own toString method. The toString method in the object class just prints out the address of where that thing is. Okay. And here is the Java doc for that. And you can see the methods. If I zoom in a little bit, you can see this clone method, which creates a copy. We'll worry about that later. Equals method. And if you're going to override the equals method, your equals method has to say object here. Otherwise, if you say, like, if you make an equals method for your student class and you say student S, that's called overloading. You've made a different equals method. You break that relationship. That's why it's a little more complicated now to write the equals method. There's there's the toString method, and there's a bunch of other stuff we don't care about. Yeah. There's always way more than we want. But so the object class defines clone equals toString, and we have to override them exactly the way they're written so that we do things right. So this is why the pattern for the equals method is kind of complicated. And this is what I'm going to ask you to do. I wish we could do it. I don't know, actually, if you want to stick around after class, we can write the equals method for the person class. And then you can try writing it for the student class. Okay. But the pattern says we have to receive an object because that's how the equals method for the object class is defined. And we have to override it. We don't want to make our own version of the equals method. And so we check to see if the other is an instance of the class that we're trying to compare. So for our person class, this would say person here. And then we'd say person that equals person other. This is casting other because this is telling us, yes, other is a name or a person or whatever. So we can cast that as the class that we're in. And then we can actually see, check the different fields. And that's what varies between these. And I'll show you that if you can stick around a couple minutes after class. The clone method is another really important thing. If you ever want to make a copy of an object, you can invoke the clone method. And that's real easy. It's just you put the constructor of your class and whatever it needs of the same fields that you're in. And now you're actually given a new copy of that thing. It's a pretty amazing thing to make a copy of an object. And to use it, you can say like Joe2 equals Joe.clone. If Joe is an object, you can invoke and clone it. And that's it. Yeah, so real fast, if you got to run, that's fine. We still have a couple minutes, though. Let's go ahead if you want to stick around. Although I guess the class ended at 8:50, didn't it? To me, it always ends at 9, sorry. So if you want to stick around, we'll just do it right now. We'll just do the person class equals method. Okay. So it's going to say public equals, and we're going to say, public Boolean, sorry. Public Boolean equals, and we're going to say, what comes next? Object, and we'll say obj. That's so that we override the one for the object class. So here it is. Actually, let's call it other. I like their use of the word other. Let's do that. Sorry? Did I forget something? What? Sorry? Oh, my cursor's in the way. Yeah. Okay, so we're going to say if other is an instance of person, and then we'll just say person that, oops, equals, and what we're going to do is we're going to cast other as a person. Because we just checked this thing says yes, other is a person. So then let's just make this variable that, which is a person variable, and we're just going to now cast other as a person so that we can now use all the person methods. Because right now, other is an object, and it doesn't have any of those methods. Because it has object stored as other stored as an object, you can't access all those person methods until you cast it as a person.
And that is the reference to the other?
Yeah, so that is going to refer to the other object, but now we're referring to it as a person reference. And a person reference can refer to all the person methods.
What is that person that equals person other?
What is what?
I don't get that person that equals person.
So you can imagine other is a reference to the thing we're trying to check equality of, but it's an object reference. So you can only invoke methods from the object class on other. So you can't say get name, for instance.
It's the other part that's confusing.
So what we did is we made a new reference variable that, and we're going to assign it a cast of other through person. So we're looking at it through a person filter kind of way, right? We're looking at this object through a person filter so we can activate all the person methods on that object.
And then you're going to check with the object that.
Yes, and we're going to check whether that is the same as this dot name is the same as that dot name. You see how kind of cool it is? So, and so really, how do we know if two names are the same? Two persons are the same? Well, they have the same name, right? So we're going to say if, so we'll just return this dot name. And this dot name is a string, so we can say dot equals that dot name. Right? If they have the same name, it's going to say, yes, these are the same persons. Otherwise, we're just going to return false, because that means, in this case, it wasn't even a person object. But I mean, if the names are not the same, it'll return false here, right? It'll return true or false depending on whether the name, this name is the same as that name or not. And then here is, it wasn't even a person object. So therefore, you can't be the same, right? It's like comparing a person with a string. It's not going to work.
You don't even need to put the else.
Sorry?
You
You don't even need to put the else. You could just say return false. You're right. Okay, it compiles. Everybody's happy. And I think I'll just leave it there. Okay. So the rest of the lab, hopefully you can noodle through this, and you know, you got to have some fun stuff to do between classes. There'll be more of this on Wednesday. But I think it's less. I think Wednesday's a little bit easier. Yep.
Wednesday you're going to go over what the quiz is about, or?
Oh.
You said we're going to have a quiz next Wednesday, and we don't have class Monday.
Yeah, I'll get to that. Also, by the way, don't leave real fast.
Do you want me to send you what we worked on?
The app output like this.
Okay, what is, okay, what, was it lab 2A? So copy paste. Oh, yeah, because, what about as, like a notepad? We could see notepad or we could WordPad?
Okay, there's a, just for practice, because you brought up the word quiz, and yes, there will be a quiz, but the great way to practice for the quizzes are to do the assessments. So there's now an assessment 2 up here, and you can log in. Oops, wrong login.
Can we redo assessment 1 then?
Unfortunately, no, but I will allow that later, though.
Okay.
Well, actually, after I grade it. You know, so if you finish up assessment 1 this week, then I'll open it up so you can redo it for practice.
But we can see, if we go through, even if we solved it, we can go in and it'll show the answer still.
No, it says solve. Because I don't want people to show their friend the answer and just have to type it in. I noticed, you know, people were explaining stuff to people, and that's the kind of interaction I like. But I don't want people to just say, "Oh, here's my answer file." Just type all this thing in, and you'll get credit for it. If you're gonna get the answer from somebody, they should explain it to you.
But it'll at least show us the questions.
Yeah, and you can still, and I can open that up for retaking it after it's graded off. So if you haven't done assessment 1 yet, go ahead. But you can see this should actually be pretty easy now. But it goes past. It goes into stacks, which we're going to talk about on Wednesday. So.
How do you exit out of this if you finish it?
Just close the browser and you go home and log in. It'll have everything stored there. Yeah. Everything you've already, all your work done will be back at home.
So to add the class file to Eclipse, you just have to drag it into its own folder and add these.
To the under source?
Under libraries, so you put it in that.
Show me where libraries is, because I don't.
So go to.
Let me pull up Eclipse here.
Well, I'll attach it just in case.
It's on my desktop.
2 hours ago.
Well, are you going to ask him?
He's showing me something real fast. So he's showing me how to grab that thing. So where would I put it? Oh, right under JRE System Library?
No, first open the folder.
I couldn't put it there?
Outside of Eclipse.
Okay.
Oh, yeah.
So.
To add the class, right?
So in there, and
Bag.class?
create a new folder.
Oh, really?
Yeah, right here?
And move bag.class.
Yeah, actually, it's better than.
Just the class file?
Yeah.
Not the C text?
Yeah.
Okay. What do I call it? Do I rename it?
You don't need to rename it. It's just any folder. So.
You compress it, right?
Or, no. So open the file folder. Is it in there?
This one? Yeah.
So then go back to Eclipse.
P-U.
Okay.
And right click back to
T-O.
refresh.
Hotmail.com.
Below export.
Okay.
And then, so right click lab 2A
Did you
again.
get the
And then properties.
I haven't done it yet.
And then under Java build tab.
Now, should I have gone into the?
Is this, was that the same folder for the Eclipse?
No, because the Eclipse one would be in my workspace.
Oh, so
That was
you
my
said
external
it
one.
needs to be in that one.
Okay, so I need to go to my workspace folder, which I think is
You just had the dark
I'll
master.
find the link
Yeah.
for it.
Alright.
it's is it users Tom? Well,
Yeah.
there it is. So I need to do this folder.
Yeah.
Okay, so I
So
go
same
into
thing.
source, and you're saying I make a new folder. Oops. And I copy the class file into there.
Yeah, I should send you a
Okay.
your email. Yeah, because I
So if I had actually
copies of
pre-made
research. I like to be able to-
that into a subfolder,
Would be
that would be faster, right?
Yeah.
Yeah, well,
Okay.
as long as.
But all the other ones I did.
So
And then what do I do?
And then right click that, refresh again.
So it picks it up. It's supposed to pick it up.
And then go right click or alt enter. Just hit alt enter.
Mine
And
is
then
I am
Java
zombie
build
food,
tab.
yahoo.com.
I am zombie food.
Yeah, all one word.
And then add class folder.
At Yahoo.
Walking Dead? Yeah.
Oh, wow.
And then under source.
No, I
There
didn't
you
read
go.
all the
And then
comics
select
though.
that.
Okay.
Do you not watch the show?
You have to select.
You know what? I think I would like to rename that though. I think it should say bag class. Just a little
Yeah,
bit.
so then after you add that,
I was like downloading them as they came on.
it picks
And
up the
then,
class file.
like something happened and I missed one, and then I, like next thing I know, I had like 3 episodes that I haven't watched yet, and I just haven't had the time to like sit down and watch.
It's the wrong one.
Yeah, because I don't
All
want
you have to do is just put it in a folder.
Just put it in a separate folder and then add
All right.
that
Oh, I'll
class
just fix that
file.
later. So let
That's
me.
inside the source folder, right?
Is it build pad you're saying? No.
Alt enter.
What does alt enter do?
That brings up the properties.
Probably.
Properties. Okay. And then I say add class folder and source. And just call it that. Okay.
No, you have to
You have to hit
select
the
it.
checkbox.
During
Check.
the comic book, he's like,
Right there.
many people, like a couple of times people have been like, you're a scary little kid.
There you go.
Yeah.
That's
Like,
fine.
you're really messed up.
There you go.
Okay. So
There you go.
now it compiles.
Yeah.
Okay.
I'm just concerned though,
Cool.
my
Awesome.
character's so much more awesome.
And does Eclipse give you that warning about the bag?
Oh
It
yeah,
does.
she gets on my nerves.
Where is that? I don't see it.
She's like
It's
more
the
more like Michelle.
yellow squiggly
You
line.
have to click on
Like
it.
that uber bad
That one?
Click,
Yeah.
and it shows right there.
Oh, it says it's a raw type.
Yeah.
Is that the one with the samurai sword?
I don't like her.
Cool. Thank you.
I haven't seen the episodes with her, but she's like
Very cool.
I just don't get it.
like
how-
so that's kind of hard.
Yeah, but I don't get how she's able
Mhm.
to master the
Can I? One.
Yep. Sure.
the long sword. It's
Oh.
not a katana. That's
I'm
actually
going to close
you
all
know, or
this.
sword or whatever. Like
Close.
no, longer. It's longer.
Wait, what'd you say? The what? Wakizushi or?
So I take this. I did this the last day, and I don't know where do I have to
I'm
upload
just sending
this.
you a reminder email.
So you need to export a jar file.
It's like she's
Uh-huh.
on the show.
Did
she's
it?
just giving everybody.
I
like,
know
a
how it's.
scalpel.
Is it done? You want to do it again?
The whole time I'm like, dude.
It's
I
clean.
get it. You're a bad.
and
I get it.
built.
It's like every scene you see her, and she's like,
Now
mad
we go
dogging
to
everybody on
the-
show, and I'm
Is that where it is?
What?
Can you show me where the jar is?
Yeah.
So basically, the uploader will.
CSI lab 1. No, it's not this. Grocery. Test. Here it is.
Okay. Cool.
But
So so now we go to the website and go to the browser and go to the class website. Yeah, 10B.
I'll be upstairs tomorrow around 1 if you want to work together.
Yeah, and then say here.
Finish up the lab and do some homework.
Around one?
down.
And then you, then you're gonna your login code, the same one you use for the quiz.
Here, whichever room you know.
First, it's your
FP.
last initial, first initial,
Come in early, maybe work out, and then I'll.
and then you have to select the jar file.
Yeah, I'm taking advantage of it because I'm on
Where's
so I might
it? So,
yeah, get as much done as I can. That way I can enjoy my weekend too.
Okay.
At least one
And
day.
then you say, I deserve 10 points.
Make it 11. He's worked hard.
Not gonna go that
Am I
far.
gonna get the lemons anymore?
Okay, it messed up.
Last semester, let us
And
go
the reason
back.
it messed up is the way NetBeans is doing the jar, it's nesting it in some folder. And Eclipse has a way of doing it so that it's in the root folder. We've got to figure out how to do that in NetBeans.
Okay.
There's too much structure. In fact, can we find the jar and just let's see. Can you find the jar in your Explorer folder?
Where?
Like open the dist folder so I can. Can you extract? Can you open up that jar file for me?
Yeah. This is here it is.
See, it's got a folder and it's got another folder,
Oh,
and then the code. It's just got to be right there. And there's a way to do that in Eclipse.
maybe it's
Some settings you can do. Unfortunately, this is Spanish, so I'm not going to be able to help you.
yeah. I'm sorry about that.
Yeah.
And okay, and another question. Well, I did the practice, but we upload everything here, and you know what it is. What it is? I mean,
Yeah.
my
It knows who you are
yeah, but
because
I
it's
mean,
based on your code.
yeah, but I mean, I can upload the first practice, maybe the final project or the first assignment.
Yeah, whatever you want.
And you, okay.
Yeah, it'll all be in one place, and then I can check it out
Okay.
later.
And another thing, the last one is this. We have to upload lab 1, right? I mean, after every class,
Yep.
we have to upload what we do, right?
Yeah, that way.
Finish it
Right.
and upload it, right? Assignments and anything else?
And the drills. SS.
What?
Those guys. You need to update your Java.
Okay. And what's this? It's the.
That's the quiz thing. That's this.
But for example, I
This thing.
did the first one.
Yeah.
Always delete what I did. You know. When I refresh, there wasn't any progress.
Okay, but it's there. You have to shut the browser down, open it again, and then log in again. It'll be there.
Oh, it was only what I did here in the class. I mean, I didn't do anything in my house but the quiz. I mean.
But you can do it at home
So
now.
we have to make the quizzes too, right?
Yeah.
And the last question is, how do you see this?
I log in and I can see your progress.
Really?
Yeah.
How?
It shows me what you did.
Oh, okay. I thought I had to.
Oh, you have
show
to. You have to set the share.
And all that.
Did you go to Prefs?
Here.
Teacher share. trebold@mpc.edu.
T.
Yep. REB. At mpc. mpc.edu. Yeah. There we go.
Oh, okay. You have access to.
So you did
my-
already. Okay.
Okay.
Yeah.
So that's it,
Mhm.
and nothing more.
Good.
I already have a lot of them made it, so
Good.
they're
Nice.
not
Fun.
so difficult.
Not for you, but for some people they are.
Maybe.